Welcome back, everyone. I'm excited to do day 2 of our completely free CCSK Certificate of Cloud Security Knowledge training course. And this is going to prepare you for the CCSK version 5 certification and exam. Yesterday, we had a wide variety of wonderful participants from all over the world, and it was a great time. And I was just so excited about it. I love running these sessions, and it was a whole lot of fun. So, all these things I'm excited about. We have another fun-filled day of a lot of cloud security, a lot of security architecture, and of course, what we'll do is we'll always talk for about 20 minutes, and then we'll take about 10 minutes of questions. And I love answering questions because I want to make you all better cybersecurity professionals. So we'll talk about that. I want to remind everyone that there is a companion e-guide or ebook that goes exactly with this. Please download it. My team created it out of the content that I created for the CCSK program. It has got hundreds of pages of study notes. You can use them directly with this course and content. So I think it'll help you prepare for the exam and be some things like cheat sheets to think about cloud security in general. And they're free, so go get them. On Thursday this week, it'll be at 11 a.m. Normally, we run our Thursday webinars at 1 p.m. Eastern Standard Time, but this week it'll be at 11 a.m. Eastern Standard Time. We will run a webinar on how to become a security architect. And in this webinar, we'll talk about everything that you do as an architect, everything, all the skills you'll need, and everything you need to learn. We'll go over the role, we'll go over training that's going to be good for you, and that'll really help you build your career. Now, if you want, you can train with us. We've got architect programs for cloud architect, enterprise architect, security architect, AI architect, and every other architect career there really is. But either way, you will know exactly the skills you need. And whether you get some of your business skills in an MBA program or whether you get them from us, you'll know those business skills that you need to get for the job. You'll know those underlying skills that you need from an architecture perspective and the underlying technology knowledge that you would need and how you would get it, because you can't get it by doing labs. And that's why almost all the certifications and SDO, I see you asked the question, those free trainings from Google and Microsoft, they're great for admins and engineers who configure things, but they have absolutely nothing to do with architecture because they're about how to, and architects are about how do we solve business problems. So we'll go over the role of exactly what we do, and we'll talk about how to get to your goals on this webinar. And if you think you're ready for an architect job, I'm happy to give you a little mini interview on that webinar. And if you're ready, I'll tell you who to go to. And if you're really great, I might even recommend a recruiter or call the recruiter on your behalf. And if not, I can recommend the kind of training that you actually need to become a great architect, depending upon the architect place that you'll actually be looking at. So we'll do that. It's all free. It is on Thursday. So hopefully at this point, people have started to join and we can start getting into our CCSK cloud security training. And this is the content of the CCSK. And we got it from the Cloud Security Alliance, since they actually make this. And of course, we supplemented it with additional things that you need to know for cloud security. So these are kind of things that I'd love you to know about. So before we begin, I want to know that you're awake, alert, and oriented. It's the medical person to me. So let me know that with a hashtag CCSK. And you know what? I always love knowing where you're from. Also, tell me in the chat box where you're from. I'm in Port St. Lucie, Florida today. Half of my family's in Greece, and my wife's in Philly today, or Philadelphia. So where are you from? So let us know where you're from. Give me a hashtag CCSK. We'll look at some of these for about a minute. And at that point, hopefully everybody gets here, and then we'll get started with the cloud security training. And I know I love this kind of thing. And please, it'll get to question time, and I love answering questions. And while we wait for this, I'll take Ice Cream's question. So what your question is, with your data center knowledge, you can afford to work less hours per week because it's harder to replace me as an architect. Well, we have to understand what architecture is. What makes you hard to be replaced by an architect is a few things. If you're in sales, it's the amount of revenue you bring in. And it's the satisfaction of your clients with the architectures you've designed and the impact to their actual business. So data science is great. It really is absolutely wonderful, but more of that is engineering. Now, what you can take out of the data science is understanding the various types of machine learning and AI that is actually out there, which is huge. The ability to understand, for example, a vast amount of data and be able to mine that. Yes, that's absolutely great because AI cannot translate that to humans. And that's the key to remember. There's lots of skills that we can take that are really, really great. And you could take them with you. If a data scientist would also have very good knowledge of the various AI types of things that are out there and how to mine through data and how to make predictive references, for example, predictions. Now, again, that could be tied into architecture by talking about how to use AI to help businesses make better decisions. So keep that in the mind. Those are the kind of things you can take with you, but not the knowing how to code in Python or R or any of those other things, but the knowledge of data hygiene practices and the knowledge of pulling data and cleaning it up and moving it and normalizing and mapping, reducing, and databases themselves and big data and what you can do with that data. That's going to be great for you. But realistically speaking, what keeps you employed is, are you making a difference in the business? Meaning, if you're there for sales and you increase sales, you're making a difference in the business. If you are there in AI and they want you to create an AI recommendation engine and your AI recommendation engine increases sales, again, that's going to give you a tremendous amount of job security. If you walk into the job as an architect and all of a sudden there's a bunch of junior architects and you mentor them and all of a sudden they're all senior architects, that's going to give you a big boost. So take with it all the good stuff and all the knowledge you gained about big data and AI and think about how you can apply that to solve business problems. That's going to be your expertise. And if you've got all kinds of math backgrounds too, that might actually be good too, because a math background will help you better build business cases and calculate certain risks of certain things, which again could be highly useful in an architect role. So I see Cape Con, John Johnson, CCSK, thrilled to see you. Chantel, CCSK, and Pablo in Argentina, CCSK. Balraj in California, CCSK. I love this. And Jim Weaver, CCSK. Mark over there in San Francisco, good to see you. And in Expedia Cruises downtown. All right, wonderful. People in Nigeria, I love it. Indiana. Alexandria, Virginia, this is fantastic. All right, Chris, why don't we get started with the content for the day? So let's talk about the way we can deal with risk. There's a lot of options for us. So we can mitigate a risk, for example, which is, and we'll talk a lot of this whole discussion and whole courses about risk mitigation and things like firewalls, for example, which are a risk mitigation technology. But we can also assign the risk. And that's basically where you'd basically send it to an insurance company. We can avoid the risk. We can accept the risk. We can make some determinations and things. So now we're going to talk about that next. So risk mitigation is going to be the implementation of protection mechanisms. And these can be technical protection mechanisms like a firewall, an ACL, an IDS, IPS system, a data loss prevention system, a SIEM system. They could be non-technical controls too, like policy and other things that we're talking about. Anti-malware training, anti-phishing training, anti-social engineering training. So we can, again, if we could look at the risk and say, we just can't deal with this risk, and we can assign the risk to others. Most people that have a house and have a mortgage on their house have fire insurance on their house and homeowners, because they can't afford, if the house were to burn down, to pay the bank the whole cost of their house and still have no place to live. So the banks mitigate the risk by mandating that homeowners have homeowners insurance and fire insurance, etc., which is covered in homeowners to protect the asset or the property. So that's typically risk assignment. You typically transfer the risk to someone else, typically with an insurance company, and you pay an organization and they calculate the risk, and then you pay them a little more than what they've calculated, and that's their business. Now you can also do something called risk deterrence. And risk deterrence is about implementing measures to keep people from breaking the rules. So this can be somewhat effective, but it's still an option, and it can be part of the overall enhancement of security posture. So the signs outside of your house that say, beware a dog, that's risk deterrence. When you log into something and you see a banner, and the banner says, "Welcome to this organization. If you break the rules, you're going to go to jail. If you do this, you'll be prosecuted. If you do this," that's risk deterrence. If people have burglar alarms and have alarms like a burglar alarm and cameras outside, that's a risk deterrence. Most people don't want to break into a system and then go to jail and be caught. But it's not going to stop it. It's deterring it. It's keeping good and honest people, for the most part, from committing crimes. Often you can think of risk deterrence as that. It's a little better than that, but that's really what we're dealing with. Now let's talk about risk avoidance. And sometimes this works and sometimes it doesn't work. So risk avoidance is simple. If you walk down the street and something looks scary on one side of the street and you leave, go to the other side of the street and get off of that street, that's risk avoidance, and that's a healthy level of risk avoidance. If you never leave your house because you're afraid of risk, that might be something that's a little questionable there. So the question is, we can avoid risk, but at what cost? If we never leave our house because we're afraid of risk, do we really have a great life? If we tell a business that you can never deal business with any other business because they avoided every single risk, the business will be out of business, but we avoided the risk. So we have to figure out times where we want to avoid risk and times where we don't. There may be some countries where we don't do business in. And if you don't do business in a certain country, maybe you can mitigate attacks from happening on your site by not allowing those companies to access your site in the first place, or countries to access that site, and get rid of a potential number of users. Less users means less also potential people that could hack you. It's risk avoidance in a way that doesn't hurt business. And there's lots of ways to do that as well. But generally speaking, risk avoidance will result in business loss. So we have to determine if risk avoidance is a good approach. Let's talk about risk acceptance. Risk acceptance is about accepting or agreeing to the risk. And there are times where you just have to accept risk. And that's typically where the cost of mitigating the risk is higher than the risk's exposure. For example, I just wouldn't spend $5 million to secure the photos of my cat Cindy. I just wouldn't do it. Now, I love my cat Cindy, but they're just photos. And to me, they're just not that big. So I accept the risk that even though that there's a potential loss of some cat photos being lost. Okay, fine. So I've accepted that risk. And every one of us accept risk every day. We get in our car, we accept the risk of driving in the car that day. So we're always accepting certain risks, whether it be in business or actually in our lives. Now, here's where we kind of get into things that feel a little responsible. And this is just risk rejection. No, risk rejection is just ignoring the risk. Just using hope as a management strategy that stuff doesn't occur. Burying your head in the sand and just ignoring everything that you hear. Now, this is a problem because now this, in a particular situation, exposes the company to lawsuits. It could be considered negligence. So risk rejection, not an option in most cases. So if we go through those options again, I just want to make sure everybody understands that we can mitigate the risk, which is do something about it. We can assign the risk or transfer it to someone else by buying insurance or something like that. We can deter the risk, but don't break in or we're going to go after you and your family. And we got scary dogs behind the banners. It could be something silly like that. Something like that. We've got risk avoidance, which is just don't get near any risk whatsoever. Now, there are some risks we can avoid and others we don't, but generally risk avoidance means loss of business loss. We can accept the risk and look at it and say, okay, it just doesn't make sense for us to mitigate this risk, or we could just be irresponsible, ignore the risk, and if and when something happens, we've got trouble. Don't recommend that. So let's talk a little bit more about risk. Let's talk about inherent risk, residual risk, and total risk. So total risk is the level of risk that an organization has to deal with if they didn't put any protections in or safeguards in place. So this is your unprotected risk. It's your total risk. How do you calculate total risk? You take your threats and then your vulnerabilities and you multiply them together times your asset value. Very similar to the way we talked about before. That's your total risk. Now, your inherent risk is going to be the amount of risk that naturally occurs, that naturally exists in an environment before anyone does anything to manage these or reduce the risks. Let's talk about residual risk. This is where it starts getting fun. Residual risk is going to be the type of risks after we've done something about it. So residual risk is going to be the risk that we have, get rid minus the risk reduced by our safeguards, and that's going to be residual risk, because we can't get rid of all risk. So why so many calculations I've alluded to before? You can't manage a risk you don't understand. You can't architect a security solution if you don't know what you're protecting. So you have to quantify the risk, and you have to understand what the risk is to the business. Now, we also have to report these risks. These kind of risks need to be communicated to the various risk managers, because risk, there's going to be a lot of people in a business that are assigned with managing risk. So we need to document the risks, communicate to the organization's risk management people, and then they're going to communicate their findings, and you'll communicate your findings. By the time you're done, you're going to report all these risks. There'll be documentation of organization's risk and its risk mitigation plans. And that way organizations know what they're doing. And ultimately it turns into this document that's typically called the risk register. And this is going to be a detailed and extensive document. And it's often going to contain more information than a business leader is ever even going to need. But it's used for high-level communications from risk professionals. And they'll do things like risk matrices and heat maps, and always to try to summarize all these calculations of risk in a manner that the executives can actually understand and still be able to run their business along the way, instead of deep diving into something that would take weeks to understand. So that's why this kind of information is typically provided. And this method enables leaders to be able to quickly identify problems and concentrate on fixes of the most critical risks to their business. Now, when we're dealing with risk reporting, we're going to have to be careful how we communicate these things. Different situations are going to require different types of communications. There are going to be some things that are going to be urgent, that are going to need urgent updates to key stakeholders. They're almost an emergency. And then there's going to be other things that are things we can plan to do in the next few years. And any kind of information security manager, any kind of architect, any kind of anybody working in security at a higher level really needs to be focused on, keeping these risks in check, constantly looking at new risks, constant risk reporting along the way. And ideally, these reports are actually fairly tailored. So they need to be created with the audience in mind, to make sure the audience will develop a clear understanding of the information, its context, and what it can do to further reduce risk to the organization. Continuing our discussion on risk management, I'd like to talk about some cloud computing specific risks, some risks that we didn't have prior to cloud computing, because we're going to have to mitigate or at least understand these risks. The first thing to think about is, in every situation, let's talk about the legal liability of a breach. So at the end of the day, if a customer is hosted on the cloud provider, let's say a customer ABC, and the customer is hacked because the cloud provider was hacked, the customer is legally responsible. If the customer was hacked on the cloud because of their own wrongdoing, the customer is still responsible. If the customer was attacked because of a weakness inside of the cloud provider system, again, the customer is still responsible. So at the end of the day, ultimate responsibility lies in the end customer. So when working with the cloud, you basically have to accept the risk that you could be held financially responsible or more for someone else's mistake of a cloud provider. So organizations need to understand that. Now, in some days, the environments, the customer potentially could collect some remedies by going after the cloud provider, potentially to recoup some of that, but understand the cloud providers have armies of lawyers and there's contracts, and we'll talk about contracts going back and forth as a risk mitigation approach. But just understand that. So if there's any negative publicity because the customer it's going to be on the customer's end. If there's loss in trust of the customer and the end company, it's going to be on the customer regardless of where the problem occurred. And financial responsibility is not it. So imagine an organization had their systems in a cloud, and for some reason they weren't in more than one cloud, even though most companies are. But it was a hospital; their systems were in just a single cloud. That cloud had a denial of service attack, and that cloud went down. And then the medical systems in the hospital didn't work, and someone died. At the end of the day, that hospital is going to be responsible for that patient death, not the cloud provider. Now, I'm sure there's lawsuits that go back and forth, but there are serious repercussions for the customer that we have to understand, because the customer is ultimately liable. So along the way, one of the risk mitigation approaches is actually a negotiation of responsibilities. And this means, when there's contracts going back and forth, the end customer and the provider have contracts. They all come up with a service contract, and it's going to be influenced by the nature of the cloud service, the model that's being purchased. There might be diagrammic representation. So contracts may actually include some legal liability language around it. Now, we have to understand there's going to be a conflicting perspective between the cloud provider and the customer. So the cloud customer is always going to be focused on protecting their data, and that's their job, their production environment, keep protecting their environment from breaches, failures, and availability. But the cloud provider is really focused on the security and operations of its data center. The customer is really focused on maximizing control over their data, their administrative power, and their insight, and their logging. But you're going to get less of that in the cloud provider because they own the underlying physical systems. The provider wants to make sure you can't do too much to their systems, anything that you could do to damage their systems. So they're going to be seriously limiting you. They're going to be very restrictive on various controls and procedures you may do. For example, you may not be able to do serious stress testing and penetration testing of your web apps on a cloud provider because they won't let you. So we always have to consider these and look at it in a holistic environment. Now, this means if a customer and a cloud provider are negotiating an agreement, both parties may have different goals. So generally speaking, in a negotiation, there's that adversarial dynamic. But when new customers go to the cloud, they may need to specify specific legal contracts that would help them mitigate their risks along the way. So let's talk about the various risks by cloud computing model. We'll talk about private clouds, community clouds, public clouds, hybrid clouds, what have you. So we defined a private cloud before. Remember, I drew a data center out for you in the first video, and we showed how the data center would be built, and then we talked about the cloud software, which could be put on top of it, VMware, OpenStack, or Nutanix. Now, in this environment, the customer has the most control. Now, in this environment, the customer can use as much security as they want. Now, this is basically a self-hosted environment. Now, I want to make it very clear. In this environment, if we have highly skilled people, we have a much greater security environment. Much, much, much greater in this particular environment. Now, if we don't have skillful people, we're not. And a lot of that is because on the cloud, we have the risk of the cloud provider being hacked, but we also have the risk of us being hacked. But also the cloud provider has much softer perimeters. And I'll show you what I mean by softer perimeters. Let me draw this out for you. So in a normal environment, in a normal private cloud, it's going to look something like this. You're going to have your protected internal network. And what I mean by protected is nothing can come in from the outside world because it's all firewalled off. So now inside of here, what we typically have, we're going to have network security, things like ACLs to protect subnets, for example. We're going to have some QoS, which we can do to mitigate worm type traffic and make sure critical traffic goes through. We'll be able to do VLANs, for example, as a means of segregating users and private VLANs, and in network admission control. And we have so much more we can do here in the protected network. But the way but if people understand what they're dealing with. But the reason these are pretty secure is, let's say your internet's over here. And then ultimately what you're dealing with is you've got a firewall over here. So you've got a group of firewalls. any things that are externally facing from the world are going to be in a demilitarized zone or multiple demilitarized zones off of your firewall where you're going to host, say, your web applications or things like this. So if you actually look at this carefully, and I want you to see where the hidden strength is here. Your users will be able to go out to the internet, and their internet traffic will be able to come back, but nobody on the outside world, for the most part, will be able to go through the internet through the firewall. So this is a pretty hard perimeter here that we typically have in the data center, which is really great. Now, if we go to the cloud provider, let's really talk about, in many cases, a VPC or a VNet. So in the cloud providers are already connected to the internet. Everything is already connected to the internet. So internet here, internet here, internet here, internet here. And in certain situations, well, bear with me for a second, but in certain situations, let me just try to get rid of the fill here where I can show you what I'm looking for. In certain situations, this virtual private cloud or VNet might already be connected to the internet. So here, this might be where your internet, this might be where your web server might be. And now in a different subnet, for example, you might have different servers. And it's, yeah, sure, this isn't a private subnet, and they're separated by subnets, and they're separated by ACLs. But here you've got an ACL perimeter, realistically speaking, between things that can reach the internet and things that can reach your servers. And over here, we've got next generation firewalls, which are a whole lot more secure. We can still run all our internal security and ACLs for our internal things, but the external stuff's outside the firewall, outside of our network, and we can do a lot more there. So we don't have some of those same risks that we have in the cloud provider. The challenge here is it takes some level of sophistication and knowledge to do it. And for organizations that lack the knowledge and sophistication, they're typically better and safer in a public cloud. Now, let's talk about where this is good. So the private cloud, realistically speaking, gives you the most control. It ultimately has the scalability limitations of whatever stuff you have sitting around in your data center. And, for the purposes of exam, your private cloud is more expensive. Your data center is more expensive than the public cloud. In terms of reality, you might find that the data center is substantially cheaper, but, we have to pass the exam here as well. Now, when you're dealing with a private cloud, the organizations still have risks. They have the risk of one of their internal people maliciously, for example, doing something wrong. They still risk external attacks. You've still got the risk of natural disasters. You have the risk of regulatory non-compliance, because if you don't design your systems for compliance purposes, you could be fined. Where the cloud providers typically already have gone through various compliance protocols, so that kind of reduces the risk when you use them. But malware is obviously an issue, but again, it's still an issue on the cloud. So all in all, not many risks by comparison. Now, the next thing we can talk about is a community cloud. Now, this is a different kind of environment. Now, here, maybe you have 10 organizations that are together that pool together resources and create their own cloud and then share them. Now, this adds some resiliency because there's a shared ownership among a bunch of organizations. It gives them the budget to buy extra capacity. And the reality is it can be focused on the needs of that particular business by optimizing the cloud. So there's a lot of good things here. But now the risk is you've got multiple hands managing the kitchen, so to speak, of different organizations could potentially be a risk. And each node from each different organization could potentially be a vector to the cloud if it's not designed properly. So the community cloud gives us some benefits of shared costs. Access and control is also shared, so we'll kind of keep that through other organizations. There's typically no need for centralized administration for performance monitoring, which makes it easy for businesses to do their own thing that are part of that community cloud. But you're typically getting out of a lack of standards and the lack of identical proper processes across clouds, and that typically promotes a big risk. So that brings us into the hybrid cloud. We talked about hybrid clouds before, where a hybrid cloud is where you have your data center and you connect it to a cloud. Now, this is going to be one of the most flexible environments. It's typically going to be one of the most effective environments, and it's typically going to be the highest performance because the data center usually gives us better performance because we have less network latency, more network control, and we can use different types of storage in a data center on the server versus block storage, for example, that'll be much faster when we want to use it. Now, the risk would be is if we don't manage it correctly, and there's a lot of moving parts, we do something wrong. The hybrid cloud gives us a lot of benefits by reducing our risks of a single point of failure because we could have a data center connected to a cloud in two different availability zones, and now we've got two sets of environments. Lots of things can happen and we can still be up. Things that need compliance, we could potentially put them in the cloud because it's so much easier to do some of these compliance things in the cloud in many cases because they've already worked so hard for them. And in our data center, we can do things that don't matter like that or higher performance workloads. So, there's still plenty of risk here. Now you're dealing with two parties. The cloud provider can get hacked or you could get hacked, but there's lots of other things that come along with it as well. Greater availability, tuning your systems, greater cost, efficiency. So organizations need to think about it. Now, of course, the organization can go to a single public cloud or multiple public clouds. If the organization goes to a single public cloud, well, now they risk availability because now they've introduced single points of failure, regardless of how many availability zones or data centers or regions you use, because the cloud providers share a common network and control plane. So there's lots of things that can take a cloud provider down. So, but with the public cloud, you have to understand the risk is you lose a lot of control and security. You lose almost all the control and network security that you had in the data center, at least a lot of the really important things we just can't do on the cloud. And we've got to worry about the cloud provider getting hacked and us. So those are the two risks when we deal with a cloud provider. In our data center, we're just protecting our stuff. And in the cloud, we've got our stuff, plus we're hosted on the cloud. And what if somebody actually attacks the cloud? So very similar risk of any kind of shared risk in a multi-tenant environment. So lots of loss of control. And we have to be careful with the public cloud to avoid vendor lock-in. And it's pretty easy to do this. So for the most part, if you go through a certification and anything that they met, like an AWS, Azure, or a Google certification, and anything that the company made themselves, like a DynamoDB or an Amazon Aurora or an Elastic Compute Service, for the most of that part, if you use those types of services, you tend to get locked into the vendor. But if you use open standard services like MySQL or Postgres or Apache Cassandra or MongoDB, for example, or Kubernetes or instead of ECS, something like that, you won't get locked in. So there's always the lock-in risk, but that's only if you choose choices that are proprietary. Otherwise, the cloud providers typically won't lock you in. Because the concern is that you might have a contract that could lock you in. There's lots of reasons people could, but the technical lock-in typically and the dependency on the cloud provider typically comes when people use those cloud provider proprietary services. So we have to understand that when we take data out of the provider's data center and bring it back to our business, that could cost us money. We have to understand that if we use the cloud provider's proprietary stuff, then we're stuck in proprietary formats, and that's going to be technical debt later, which is going to make it much harder to innovate with other systems later. We have to understand that there's some contractual contracts often with cloud providers. So we have to make sure these contracts don't cause us to be locked in either. We also have to be very active and concerned with our regulatory constraints and making sure that the contracts specify that regulatory constraints will be maintained. Now, we also want to make sure that our contract terms are favorable. So typically speaking, we may have our lawyers and the cloud providers' lawyers negotiating contracts together, especially in large-scale environments. So avoid vendor lock-in as a rule, unless there's a reason to use a proprietary technology where the cost of being locked into the vendor outweighs the risk of the challenges that you'll have later. So think about all that's necessary. It's appropriate physical network bandwidth to go back and forth in and out of the cloud. Make sure the cloud provider can handle the kind of data. Make sure the provider's data, things that you're talking about are able to come in and come out. So these are the things that need to be investigated as part of your architecture, then migrating to our cloud and in these cloud contracts that wouldn't be negotiated. Now, we also have to think about vendor lockout, and this is a risk. And vendor lockout would occur, say, if a cloud provider were to go bankrupt, or out of business, or ceases operations. And this can impact a customer's ability to recover the data. We also have to worry about a cloud vendor kicking somebody out of their cloud. The AWS example with Parler. And I can't say whether it was a right or wrong decision, but Parler was hosted in AWS. AWS didn't agree with their business in some way, shape, or form. And AWS basically said, you're no longer welcome in our cloud. So we always have to plan that risk when we're dealing with the chance of vendor lock-in or vendor lock-out. We always have to manage these things. So we have to evaluate the provider's financial performance and market performance and stability, which is why you may see big companies typically getting more of the business than small companies because people are afraid to invest in a small company. That's one of the reasons. And realistically speaking, is that business a market leader? Are they constantly evolving? Are they constantly how well are they training their customers? Okay, we are back. So I'm here to take some questions. I always look forward to taking some questions. And before I get to the question, I want to make sure two things. One is to make sure you know that we have a guide, a very comprehensive guide to assist you with the CCSK certification. And you can get it by clicking on the link. My team will drop it in the team. Now, this is an extensive guide. And why did we write an extensive guide? Why didn't we give you a 30, 40-page guide that had no content in it? Because at the end of the day, when you go on an interview, we hiring managers ask you questions. And if someone's got a certification and we ask them a question and what we get is but and made up answers, what happens 99% of the time when we interview people, we can't hire those. So we wanted to give you enough that you actually have the ability to learn something. And we went way above and beyond. We gave you some things from the CISSP when it comes to IAM because we lost these boundaries. And we may have given you a lot of comprehensive reading because we want you to get hired. We want you to have a better career and we want you to have a better life. So that's why our information is going to be comprehensive. If we gave you a 30-page guide, I promise you, you wouldn't get anywhere. And if you take what we have and you summarize it with AI, here's the reality. You won't know enough to pass an interview and you'll be sitting on the sidelines. So we want the best for you. So go out there and get it. And if you don't want to read our guide, get the guide from directly from the Cloud Security Alliance and read that too. I would read both and read all the books out there and if they're as well, because that's what it takes to be the best. Just because you're good skills, that doesn't protect you. You have to be great. You have to be always there. You have to be willing to help and you have to be willing to go above and beyond. So go above and beyond and actually get yourself some skills and have a different life, have a better life. But you don't get there by staying comfortable. You get there by really putting the oomph in it to get there. When I did my CCIE, I'm not joking. I woke up at 5 o'clock every morning and I studied from 5 to 8. And guess what? Then I worked. And when I got home from work, I spent 5 to 6 or 6 or something like that, an hour with my wife. And then I'd study for 3 more hours. I'd read for more hours. And I read almost 75,000 pages. And I put together 1,000 lab hours for the CCIE exam. And truth be told, it changed my life. So I always want you to think, well, you want to be the best. You got to be great. Go above and beyond because the people that summarize it with AI, the people that are there aren't going to get to the top. I want you to get to the top. I want you to be great. So go over the guide 3, 4, 5, 6 times. Go through the guide from the CCSK 5, 6 times. Really learn this material. Who has the next question? I just want the best for all of you. Is the exam multiple choice questions? And what was the other part of it? And what else? So to give you a little information about the exam, it's about 60 multiple choice questions, and you'll need a score of 80% or higher. So it's actually an open book exam. It's a relatively easy exam, and you have 90 minutes to pass it. So kind of keep that in the back of your mind. What recommendations can be provided to help study the material? Read our guide, watch this video, and get an official guide from the Cloud Security Alliance and read that as well. That's what I would do. In fact, that's what I always advise is we create materials. But I always want you to go through the manufacturer's documentation or the vendor's documentation for whatever we do. And we typically recommend whatever books the vendor read. So, for example, when we teach a CCNA class, we recommend that you read the official Cisco Press CCNA curriculum, which is typically written by Wendell Odom, following us. So while we follow the Cisco curriculum, and they follow the Cisco curriculum, when you do that, you're actually hearing from two sets of the sources. And I spent a life in a lifetime in at Cisco and trained a lot of engineers and architects at Cisco as well. So when you heard it from me, it was coming from Cisco, and when you heard it, for example, from Wendell Odom, again, it's coming from Cisco. Chris, go to the next one. Which cloud vendor has better customer service, AWS, Azure, or Google? None. The service is based upon the person you call in support. They're either good or they're not. Now, at Elaborate, the more you spend with a provider, the greater your service level will be. So if you're a big customer, you'll get preferred service, and you'll have service delivery executives that may manage your account, and you'll get incredible service. So the different question is, how much money are you willing to spend? How big are you? Because how big you are determines the level of account executives or sales reps that you get. And then depending upon how big you are, the leadership will also get involved of your account. And if you're big enough, you'll get a director level person as just your representative from a service support perspective, as well as a dedicated account team. So that's really going to determine the level of service, how much you're willing to spend with the cloud providers. Would a master's in educational leadership help as a cloud security architect? Well, if you already have one, yes, because in security architecture, we have to develop training plans and training curriculums, for example. So that could be there. And you could take that with you. And depending upon what kind of leadership, it could be very valuable depending upon the leadership skills. But I don't know what's taught there. But if they're doing the same kind of leadership skills there that they would do in their MBA programs, that'll be highly beneficial to you. Now, if you were just starting out and said, what kind of master's degree should I get for security architecture? I'd tell you it's an MBA for all the business. But the reality is, I've seen plenty of people without degrees actually get architect jobs. So, and anytime you're more educated, you can use that as well, and kind of keep that in the back of your mind. So, definitely can help you. Any participation certificate for us after the boot camp? I don't do participation certificates. That's like a participation trophy where everybody that goes to a game and everybody gets a trophy, whether they won or not. And at the end of the day, here's the reality. Here's work. I've got, I interview 100 people, 5,000 people applied, and I hire one. So nobody cares about certificates that somebody lists. They care about which certifications you passed, what skills you have, and what you can do. So how can I validate participation if I don't know that you're here? I can't guarantee that. And if I did, it would be worthless, because then I'd be guaranteeing or saying people have done stuff that I don't even know what they're actually there. So kind of keep that in the back of your mind. The test, the exam, that is the win. And I'll tell you, I've seen people that have listed 50 little mini courses with no certificates on the resume. I get them every day and I toss them immediately in the trash, because who are they trying to kid? They're going to kid me that they went to something, they didn't even attend it, or they may or not have attended it. I have no way to know. And then I ask them a question based upon the content they don't know. So pass the exam. That's your win. That's the thing that helps you get an interview, and then it's your knowledge that gets you hired. We do this to train the world for people that actually are looking for skills, that want to have opportunities. We're really trying to change people, change the world, and we're doing this for free. But I can't give invalid certificates by not knowing what you've known or not knowing what you've done. And how would I validate it? So that's why I don't do these things. But you can actually take the real exam, and that you can put on your resume, and that might actually get you an interview. But a certificate of participation, that's like somebody telling me I have 100 participation trophies in something. And I'd say, okay, when did you win and get a gold medal, a silver medal, or a bronze medal? And they're like, there were no medals. I'm like, okay, so they don't mean anything. So that's what we're trying to do here. Any others, Chris? What is the validation of the CCS key cert for job opportunity, despite the skills will speak for itself? So here's the reality. So it can help you get an interview. Now, what you know about security, Abdullah, is going to determine what you get hired. I've had people with 0 certifications, but their skills were so good they were hired anyway. I've worked with people. I worked with a gentleman named Ted many years ago, about 20 years ago, when I was designing systems for the largest market maker in the world on NASDAQ. And they were doing about 2 billion trades per day on these trading systems. They were the fastest in the world. And this guy, Ted, didn't have a single certification, but he would have ran circles around half of the CCIEs and CISSPs that I know. So all you're using certification for is bait. What will I get me an interview? And then it's going to be all the things you study, your knowledge of network security, your knowledge of IAM, your knowledge of secure coding, for example, and secure development, your knowledge of how to craft a security policy, for example, your knowledge of how to create business continuity plans and disaster recovery plans, for example, your knowledge on data security and data classification and data loss prevention. These are skills that will keep you employed. And these are critical skills for security professionals like security architects. But for example, kind of keep that in the back of your mind. It's here to validate that you know something, and then it's designed to get you an interview. And once you get that interview, it's up to you to win it. And I've never been on an interview that I've not gotten hired for, because I always spend a ton of time preparing for an interview, and I don't apply for jobs that I'm not capable of doing. Actually, I don't apply for jobs at all. I just call a recruiter and they tell me, Mike, I set you up with an interview with someone. So kind of keep this in the back of your mind. And I kind of hope this actually works and it makes sense to you. So good thing to get you interviews, and it's up to your knowledge. But I'm going way above in the knowledge here. We're giving you a lot more than based in the curriculum. Do I have any literature for sale? If you do, where can you get it? Aladabert, we don't have any literature for sale. We typically give away what everybody else charges for, and that's all free. The only thing that we charge for are life-changing career development programs, where we're taking someone and we're training them for an entire career. All the business skills, all the technical skills needed for that job, and typically speaking, our costs are about 2 days pay or 3 days pay or less for the average graduate of ours. We're just in this to change life. I retired, and this is what I wanted to do, create the next generation of tech leaders. And we do a lot of free for those reasons. And whenever we do charge people for it, is we will teach you the entire career, and you'll stay in our program until you're hired, kind of thing, because that's all about changing lives. And this is about doing as much as we can to change lives as well. If you want to concentrate on specific cloud services like AWS, what are the importance of AWS security services mandatory to learn? So I'd point you to AWS, but for Ash, if you want to just learn AWS security services, you'll be in the unemployment line for the rest of your life. 98% of enterprises are multi-cloud, and 89% of all businesses are multi-cloud, which means you won't be able to use most of the AWS services. And if that's what you focus on or what you learn, nobody can really hire you, because they're going to be using security services from Palo Alto, and they're going to be using them from Cisco, and they're going to be using them from Fortinet, and they're going to be using them from IAM vendors. And if you don't know that, and all you know is a couple of AWS services, there's nothing that I could hire that person for. So sure, you can do the AWS Advanced Security Advanced, and it has no security in it whatsoever, but it will tell you about the names of the AWS services. Just make sure you don't use most of them in real life, because they don't work multi-cloud. And there's a massive difference between the way an AWS WAF works when it comes to protection versus a Palo Alto next generation WAF. And there's many different things that would occur. So in many cases, I couldn't even use the AWS services, even if I wanted to. I need more industrial services that run on both clouds. So that's the last of my advice: is learn cloud, learn security, and stay away from the vendor. Because imagine if the only thing you could drive was a Toyota. But what if you rented a car, or your car broke down and you needed to borrow a car and it's not a Toyota? That's the equivalent of learning just a single cloud. and only 2% of companies could hire you because 98% are multi-cloud. I hope that makes sense. So I think we need to get back to the content, but if there's other questions, I'm happy to go back to them next time. So Chris, let's go back to the content. Now, another thing we need to think about with cloud providing is the jurisdictional suitability of it, because we need to understand where the cloud providers' systems are, where their operational locations are, identify where their data centers are, and where they store their stuff. We need to make sure that the data handling complies with any relevant recommendations and doesn't cross any business boundaries. So we might have certain data that must be kept inside of, say, our country. And if you go to a cloud provider and all of a sudden they replicate your data to another country, that could cause you to have challenges. So we always need to think about that and the practices. We also always want to think about the supply chain dependencies of our providers as well. And we want to make sure that our vendors can get what they need when they need it. So we need to get a lot of information like that. Now, we have to understand that can stay up to date with cloud statutes and any legal environments that could not work with us. And then we always have to account for things that we don't even plan on, like Brexit, for example, where that referendum basically changed the UK from being in the EU. And that could change so many things, especially where your data could be. So realize that the cloud is a multi-tenant environment. You and maybe 100,000 other customers are all sharing the same space. So realistically speaking, it's a scalable environment, but it is a multi-tenant environment. So it puts us into various environments. There's ultimately, we have to worry about conflict of interest because the providers people can't, in generally speaking, manage the data systems of an organization unless they do it as part of a managed service agreement. So the provider is always going to have to try to stay out of areas of conflict of interest. We also have to worry about an escalation of privilege attack. So and this is realistically speaking where an authorized user is going to gain increased access. So what if, for example, one of the people who has good privileges in the cloud provider's account got hacked? What could that do to us? So we're always thinking about information like that. We do worry about something called information bleed because it's a multi-tenant environment. And realistically speaking, I want you to think about this. So if I draw this out for you and you really see what this could actually look like. So let's say this is a block storage environment or an object storage environment. It really doesn't matter at a cloud provider. Now, if we really see what's going on here, this thing is going to be filled with a whole lot of hard drives. Hold on, let's make a quick little RAID array here. We'll make a couple of these. And these are all hard drives. And this device is going to be filled with hard drives. Let's move this over, make it look a little prettier. So all these are different hard drives where the data is going to be. But when you actually realize that what's coming in here, this could, on the way in, accessing the system, this could be 1,000 customers or more. Now, what's going on is we've got these block storage volumes. They're virtual drives. They're carved out. So theoretically, we have no bleed or information from one of these drives to another drive, from a customer to a customer, because they're virtualized. But there is still the risk that somehow one customer's data is being accessed by another customer. And we don't have that risk in our data center because we don't have any other customers. I didn't say it was a big risk. Now, we also have to think about legal challenges in cloud computing. Now, let's say we've got something in our data center. Somebody could just subpoena and grab the hard drive or a server. And if we're in a cloud environment, and let's say a customer does something wrong, now, what is going to be subpoenaed? What information is going to be there? If they take the entire RAID array or the cloud storage environment, Ultimately, they actually have access to your data, although they don't have your encryption keys, which is protecting your data. But your data in a legal environment, if it's seized, hundreds or thousands of customers' data could also be taken in by law enforcement or seized. And who knows what secret formulas could come out along the way? Shouldn't. So I just want you to understand that's one of the risks from a storage environment. So what we're going to do now is we'll get involved by talking about the various risks by cloud service model. Remember, we'll talk about infrastructure as a service, for example, and platform as a service and software as a service. So if we look at infrastructure as a service environments, the customer has the most control. Realistically, in this environment, they have control over all their stuff inside of their virtual data center. So we still have the risk of personnel threats, malicious or negligent users with access to the systems. We typically have these things. And we have the risk that they damage something on the cloud provider systems. And we have the risk that we and our employees typically do things. Now, with infrastructure as a service, we still have the same external risk we've always had, like hacking events, malware, DDoS attacks, on-path, man-in-the-middle attacks, what have you. All that stuff is the same as it used to be. But realistically speaking here, now I'm going to tell you right now, there is a major shortage of people that know anything for the most part in cloud computing and have good cloud computing skills. And because of these, there have been a tremendous number of security events. So there is a critical shortage of people that actually understand cloud security. So not only is it a great career for a cloud architect or a cloud security architect, and even to a degree security engineers, but there's a lot to be protected, and it's really challenging for employers to find people, which is a big risk to their environments. So now, if we deal with platform as a service by comparison, remember this is typically where you upload your code and it's hosted for you and it's application virtualization, or it could be using a cloud provider's proprietary serverless type databases or things like that. So we have to worry about operating system updates that the cloud provider might put, or even we would do in our data center. They update something in a platform as a service environment and it breaks one of our systems. That risk always does occur. We always have to worry about when software is developed. A lot of times developers put backdoors in the systems as part of the process of being able to access the systems. And those systems should be closed, and we don't typically have the ability to look at the applications underlying the cloud provider's underlying stuff to see if there's any backdoors there. So we have to trust that it's been there. And trust is a pretty rough way to trust when you can't see things. So just keep that in the back of your mind. Now, with platform as a service, we're dealing with virtualized operating systems, so they're inheriting the associated threats of the operating systems. Now, typically speaking, with software as a service, remember, almost all of this is done for you. So basically, we're putting our system in something that's hosted by somebody else, that's managed by somebody else. The data is probably going to be in a proprietary format, which now means we've got the risk of trying to integrate that with other things later and vendor lock-in. Realistically speaking, the SaaS environment, we have no control over the way those applications are secured at the cloud providers. So we're basically hoping and relying on browser access and APIs. And, there's other things that we could do that might be a little stronger to secure things. So let's talk about some attacks that could occur. And let's talk about how common and uncommon attacks, but I want you to understand these are the types of risks you have in a virtualized or cloud computing environment. So the first thing is a hypervisor attack. And remember, we have two different hypervisors, the type 1 and the type 2. I'll go draw it out in case you don't actually remember, but let's do it. So realistically speaking, here's what I mean by a hypervisor attack. So in this particular environment, we've got a server. And then the server itself is going to have a hypervisor. And then ultimately what we're going to do is we're going to have multiple virtual machines that are sitting on the server. And the virtual machine will have its operating system, and then it's going to have the application and dependencies. And then we're going to have a bunch of these environments. Let me just say, app plus DEP, dependencies. So we might have a whole lot of these. And this is what you would see in a normal type 1 hypervisor that you would typically deal with in a data center environment. And this is how server virtualizations worked since 1999 when VMware invented it. And now the cloud providers do something similar. Now, just in case you didn't know, if you ever ran a virtual machine on your PC, you might use what's called a type 2 hypervisor. And here's where you might have your Mac. It might be like your MacBook or your little or any notebook that you have, your little convenient thing that you bring with you somewhere so you can work, so you don't carry something that weighs like 150 pounds with you. And while you're at it, let's say you're on a Mac, you need to do something in Windows, you have a Windows virtual machine. In that environment, that virtual machine, what you're talking about, is going to be, the hypervisor will be inside the operating system, and that's what you call a type 2 hypervisor. But that's more for, us, for our convenience. Businesses don't really run their systems with type 2 hypervisors. They use type 1 hypervisors. So let's go back to this. So going back to this type of environment, what are we really worried about from a hypervisor attack? It's basically called a guest escape, where you worry that someone from this virtual machine could get out of this virtual machine and then get into another virtual machine. Now, that's called a guest escape. It's a very uncommon thing to occur because for the most part, you'd have to get out of this virtual machine. You'd have to hack and break in that hypervisor to get it to allow you to go to another machine, which it shouldn't seem to do. So that is the risk that we're typically dealing with virtual machines in infrastructure as a service. Now, the next risk is information bleed. And this would be some kind of malfunction or failure that would cause data processing in one virtualization instance to basically be detected by other instances potentially on the same host. So we also worry about the concept of information going from kind of like one of these systems to another system. So we do always worry about these types of attacks occurring on hypervisors. They're not that common, but these are the types of things that could occur. Now let's talk about another virtualization risk in the cloud. Your data is on this data array, and like I mentioned, somebody takes the data is seized. So now your organization is, now their data has been taken. Now, if we look at some other virtualization risks in the cloud and the data center, we have to remember traditional data centers have very hard perimeters. Cloud providers are all software-based perimeters, and things are connected to the internet. So that puts us in another environment, which is generally speaking why we've migrated towards zero trust. So there's plenty of threats in cloud computing that can occur, but a lot of these threats are the same threats that can occur in our business. Malware or malicious software that could cause data loss, loss of control of devices, and operational interruptions. Now, generally speaking, it's less likely in a software as a service environment, but it's still possible through a browser. But these things are there. So, on our host, we can put some anti-malware protection. And if we're using good next generation firewalls, not the cloud native ones per se, but these newer, better next generation behavioral analysis, they can look at the code as traffic is even coming in. And now you have a much better malware strategy by using real heavy duty enterprise grade next generation firewalls along with endpoint protection. DDoS attacks, where basically someone tries to take an organization's services down. Again, cloud risk, but also off-cloud risk. So man-in-the-middle attack, for example, is another type of attack that can occur, which is always a big threat, and it's typically based on eavesdropping. I'll just draw you a man-in-the-middle attack so you can see it. Again, this can actually occur in any environment where you're actually at, but it's still a risk. This is a data center or cloud one. So let's say I want to talk to my wife, Lisa. And let's say for some reason, I send a message to what I think is Lisa, but it's really not Lisa. It's actually someone. It's actually someone pretending to be Lisa. So we'll call this not Lisa. And a man-in-the-middle attack could be it could be one of these two situations. I could be talking to not Lisa when I think I'm talking to not Lisa, give a lot of information to not Lisa, and then not Lisa passes the information back to Lisa, but I don't know that not Lisa's there. And then all of a sudden, now least it provides me more proprietary privileged information that we don't want anybody to see, and then not Lisa sees it as well. That's typically what you typically think of a man-in-the-middle attack. But realistically speaking, if we ran encryption between endpoints, that would mitigate that problem, because the endpoints would have to prove they are who they claim to be. But it could also be just somebody in an impersonation type attack you typically think of, where I think I'm talking to Lisa, someone pretends to be Lisa, but it's not Lisa. So these are the types of communication types of attacks that you typically think about. Man in the middle. Man in the middle is pretty easy to execute if you were basically, like if you were on the same local area network and you had a wiretap between these two, this type of attack would be really easy, because you could put a protocol analyzer on the network and see the messages that are going back and forth. Encryption is typically the solution to manage risk of theft or loss. Again, data center cloud, people conceal stuff. This gets a lot more in a bring your own device environment, where people store information on devices they purchased, and then when they want to leave the company, they take it with them. So these are things we always have to plan around. We also have to always think about compliance issues. And typically speaking, these are going to be greater risks in the private cloud, because most private organizations aren't experts at compliance, and the cloud providers have teams and armies of attorneys that are going to be more experts on this. Now, in cloud computing, just like our data center, we have the risk of natural disasters. Now, theoretically, the cloud providers are so redundant that if your systems were in multiple countries and multiple data centers per country, things would be okay. That the things in theory and reality don't always work that way. So, the mitigation around that is use more than one cloud and more than one availability center per cloud, or whatever the business needs. And poof, you can help mitigate some of those risks by being in more geographically dispersed environments. With cloud computing, we have to deal with the loss of policy control. We're now distributing ownership of things in various clouds, so we can help reduce that risk with a centralized, like a cloud access security broker, some kind of good standard centralized IAM solution across clouds. No, we also have to worry about with cloud computing is the loss of physical security, because we don't know what's going on at the cloud providers. And this might be even worse in a community cloud if you don't have a lot of sophistication managing physical security. Now, a huge risk in cloud computing is the lack of audit access. We just can't go walk into the cloud provider's data center and examine what they're doing. Do people look awake? Do they look like they're sleeping on the job? Does everything look tightly controlled? Does it look sloppy? We don't know. So we're going to have to read reports that are going to be out there and hope. Now, the rogue administrator, that's the concern we have in a data center and a cloud. In our data center, we have the concern of a rogue administrator doing something bad and harbinging our systems. Guess what? In the cloud, we still have the risk of a rogue administrator on our systems doing something, but we also have the risk of a disgruntled employee at the cloud provider that wants to hurt us. So, again, it's not about not using cloud computing. It's about understanding the risks and be able to say, yes, these risks are acceptable to our business, or no, we need something different. Same kind of escalation of privileged attack that we have in our data center, where someone can access to our system and do something. That's in our data center, it's just us. On the cloud, now we have the risk of someone can attack our VPC, VNet, our account, whatever you want to call it, and someone doing an escalation of privileged attack on the cloud provider and causing damage. So these are the kind of things we need to think about. And of course, we've got countermeasures. For example, for malware, we're going to use endpoint protection. We're going to use some good network-based IDS, IPS systems that are scanning the systems that are behavioral-based. We'll use good next-generation firewalls. They can honestly check for these kinds of things. Internal threats, you will create background checks. We'll look at resumes. We'll confirm it and check these things. We'll implement personal policies and specialized training and mandatory vacations and job rotations to be able to see what people are doing. We'll have to enforce solid workflow policies and separation of duties and things that we can do to mitigate the risk of internal threats. We use active surveillance and monitoring programs. We may do data masking to limit access to those that need to access data for their jobs, and so other people can't see it. We might be implementing some egress monitoring and data loss prevention strategies and solutions to make sure things don't leave our systems. Now, For external attackers, the countermeasures are going to feel fairly similar to what we've always done. We're going to harden our physical devices, our hypervisors, our virtual machines. We'll use strong access controls, make sure we've got configuration controls as well, and a good change management process. We will outsource to the right third parties. We will bring in the right firewall vendors, for example, IDS, IPS system vendors, SIEM vendors. Maybe we use a cloud access security broker to help manage all our IAM, for example, across the clouds. So we're going to do everything we can to protect our environment along the way. For an on-path, man-in-the-middle attack, just use encryption in transit. Whether it's IPsec or TLS encryption, that's going to solve that problem along the way. Social engineering, meaning somebody comes in and talks to people and asks people to do things they don't want to do. Well, same thing. We're going to educate them against doing that. How do we protect against data loss or theft or loss of devices? Well, we encrypt the data that's shared. We put very strong physical access control. We limit or disable maybe USB functionalities in systems so people can't steal data from the environment. We maintain detailed inventory controls and monitoring systems. We can remote wipe systems and portable devices. So as you can see, we're going to come up with a lot of countermeasures, and obviously we'll talk more about this through this program, but we were talking about cloud-specific risks, and then we're talking about some non-cloud-specific risks and threats, so let's just talk about it right now, and then we'll deal more later. So these are the kind of things that we need to. How do we deal with a natural disaster? Well, we use more than one cloud as one way, multiple redundancies, multiple data centers. And if we use a single cloud, at least make sure that we're using multiple parts of the world. We have to do this. We'll have to build, and we'll talk about developing disaster recovery and business continuity planning. Where business continuity planning is more about keeping the business up and operational, where disaster recovery planning is more about the IT systems and getting them up and operational. Since we're losing policy control on the cloud, we're going to have to use very strong contractual language to ensure the provider adheres to a robust security program. We're going to have to conduct detailed and heavy-duty audits in whatever means we can, or at least look at the customer's audit reports if they have them. We lose physical control, so we get heavy into anything we potentially can. If audits are not allowed, then we have to rely on a third party. So we have to insist in our contracts on significant protections of our organizations, our systems, and our data. And we need to ultimately negotiate financial liability in these contracts that we're also dealing with the cloud provider. How do you deal with a rogue administrator? Well, we put on heavy-duty controls to protect insider threats to do these things, at least what we can do for ours. Hopefully the cloud providers are doing that as well. We log all administrative activities. We make sure that our systems are secured, locked racks, real-time access monitoring, video surveillance, and even financial monitoring of people with lots of privileges to make sure that something doesn't look funny like somebody's bribing them. We make sure we put really good access control and authentication tools in for escalation of privilege. And we start correlating our logs with SIEM systems, and that's going to help us there. What could we do about if the cloud providers mess up our data, for example? Well, we'll do an offsite backup to somewhere else, to another trusted third party or another cloud provider. So what you can see is for every challenge, there's another risk mitigation. What if your data is stolen because your data is sitting on a hard drive and someone subpoenas those hard drives from the cloud providers? We'll use really strong encryption on your data. And realistically speaking, if you've got strong encryption, it's going to be hard for anyone to see your data. Put your data in multiple places. Don't put all your eggs in a single basket. And really look at each and every one of the aspects of this. So, I mean, if you think about it, there's been a lot of things that have changed in the last few years that have been out there. And there's been a lot of things that we can actually talk about. Okay, so Chris ended right before I started babbling. About 10, 20 seconds ago. All right. So we're back to take some questions. And so bring us your questions. Chris is behind the scenes and I'll bring in some questions. Daily activities of cloud security engineers. What are the prerequisites to become an awesome cloud security engineer? So first thing is we need to know what kind of security engineer. Do you want to be an offensive security engineer who breaks into systems? Or do you want to be a defensive security engineer? Because they're a completely opposite set of skills, although there is a little bit of overlap. Now, when it comes to engineers, we realistically have two kinds of engineers. And I'll describe the difference of the two. We have the junior level tactical engineers, and people can be in these roles for 20 years that are going to be extremely low paid. And these are going to be the roles where someone stares at a screen all day long and makes changes into the system. And then I'm going to separate that from the highly paid engineers. Now, the highly paid engineers are going to have people that have good communication skills and work well in teams, are going to have good, strong knowledge of the underlying systems and technology. And that means they're not just going to be clicking things and doing things. That might be only 10% of their job. They're going to be doing a lot of planning and a lot of performance tuning and a lot of optimization. They're your go-to experts. Now, this is a relatively high-paid person. Still nothing like a security architect or a cloud security architect. They always learn more or earn more, and it's typically easier to become an architect than a security engineer. But now let me get into the security engineering. In order to be able to work in any kind of cloud security environment, you're going to have to understand the cloud. That means knowledge of data centers and knowledge of, say, virtual machines, containers, container orchestration, storage area networks, the kind of applications and things we use in cloud computing, such as database, for example, and all the way those things work. Now, because a cloud engineer is going to be hands-on, they're going to need these skills. Well, a cloud architect doesn't need to touch Linux and never will. And a cloud architect will never write code. A cloud security engineer is going to need to be very familiar with Linux and very familiar with Windows. Familiar with the weaknesses in the systems, how to harden these systems, for example, like what kind of packages and things to necessarily remove. Typically speaking, your security engineer will need to have a good understanding of scripting, things like Bash shell scripting, Windows PowerShell scripting, and typically speaking, Python scripting. Again, none of these are architect skills. Architects don't need to learn any of these, and they typically earn more, but you asked engineering. So we're talking engineering. Now, the cloud engineer, typically speaking, will need to know something about DevOps practices, especially DevSecOps practices, things like application security and things that are going in there. The engineers, depending upon the security engineer they will working in, will need to know a lot more. For example, we may have network security engineers that focus on network security. So they're focusing on firewalls and IDS, IPS systems, and they're looking at egress monitoring, for example, on data loss prevention systems. And they're looking at segmentation and micro-segmentation and network level encryption and micro-segmentation of the network. Now, that's a big role that you could spend 25 years of your life mastering. And that would mean a lot of knowledge of firewalls, switches, and routers, and various cloud type technologies. Now, we also have cloud security engineers that focus on data loss prevention, and they would tend to specialize, for example, in data classification, data marking, data obfuscation, data masking kind of things, and data tokenization. And maybe focusing on data loss prevention systems and encryption of data and key management of data and those types of things. Perhaps we're also going to have people that focus on just IAM. So they're going to be people focusing on systems like Active Directory and Okta. They're going to determine who users are and what they're allowed to do. So I kind of need to know exactly what you're talking about. But a good engineer is always going to have knowledge of how the underlying systems work. And that's going to be more important than their ability to do something, because you can always read documentation to do something. But knowing the impact of one change on a system to another change, that makes people valuable. Deep knowledge makes people valuable. And also knowing what you want to do, because you could spend your life and a long time studying security, but if you don't focus on what you want, you're still never going to get to the goal. So, we have a lot of how to get your first job or question and answer sessions, and, come by. I'll dedicate, I have these 2-hour sessions every Wednesday where we can go through. And if you tell me the kind of cloud engineer you want to be or cloud security engineer, I can give you a more pristine roadmap. But I need to know a little more, because if you wanted to be a penetration tester, which is an engineer, again, we're talking about that. For anybody who wants to know about architecture careers, please join us on the Thursday webinar. We're going to have a security architect webinar. We'll go over what it is. If people have additional questions on other security careers, I don't mind. I'll answer them while we're there. It'll be live on Zoom. Bring us your questions and we'll do anything we can to answer that. So I hope I answered that question, and that'll give us the chance to get deeper. What kind of engineer do you want to be? Cloud security audit roles on demand worldwide in the future? Well, you can't go in and audit security of the cloud provider. So for the most part, it's not there. Now, the cloud security audit jobs, you're typically talking people that are going to go in and bring in an army of MBA consultants, and they're going to be selling millions and millions and millions of dollars. So what it really talks about at the end of the day, it's going to be a whole bunch of business people and then a couple of security people that are typically anywhere in the world where they're doing it, or depending upon the country and its security level. I wouldn't count on that being a long-term job. What do we have that's really good at mining through large amounts of technologies and logs, for example? We got a lot of AI that can assist with these kind of things. So we may have less people super augmented by AI to do these kind of things, to mine things. For example, we're already using SIEM systems that can literally track the logs and use AI to say, oh, we got a problem, and then do something about it. Our next generation firewalls, which is why I say you typically don't use the cloud providers' firewalls, can actually look at some providers can do this now, can actually look at what's actually going on threat-wise and say, I don't like this pattern of behavior. I'm going to stop it right then and there and now. So we've got AI in a lot of places. So how do you compete with AI? Either you don't do engineering roles and you're in architect roles, because our AI can't take away anything that architects do. The designing, the presenting, the selling, the leading, for example, of teams, the building business cases, the managing stakeholders, managing vendors, selling, all that stuff that architects do. We're not susceptible to being replaced by AI. But if we've got an engineer and they want to not be replaced by AI, then they're going to have more business skills, more communication skills, more leadership skills, and deep, super successful knowledge. And when I say deep, for example, networking has an exam called the CCIE, and it is tough. Really tough, meaning 3 million people have attempted it and less than 70,000 have passed it over the course of 30 years. So it's tough, but that's the start of what I consider entry level for an engineer, because the engineer, in order to stay employed, has to be better than the AI. So the architect, we don't have to worry about AI because everything we do is human. For the engineer, AI can code better than the bottom 30 or 40% of people. Those 30 or 40% of people no longer have an actual job because AI is better than they are. And AI doesn't complain about working, works 24 hours a day, doesn't get sick, doesn't get the flu. So the secret to engineering is to be great, to have such a deep level of expertise in something that all the other people that are there can come to you when you can always be the go-to person. So that's the secret to making engineering work. Give me a hashtag, everyone, CCSK. And that way I know you're awake, alert, and oriented. And, I often on Wednesdays come in and talk about the jobs of the future versus the jobs of the past, because we have to adapt. And as we stay ahead of the curve, either in architecture roles or AI roles or security roles, we're on the ahead. And when it comes to supply and demand, the greater the need and the shorter the supply, the better you're at. So if you stay at the bleeding edge, you'll always be there. And how do you stay at the bleeding edge? You get deep fundamentals. And when your fundamentals are deep, you're in good shape. I don't think any of these jobs are hard if you're actually properly trained, but understand you're going to work in any of these jobs we're at. I don't think they're hard. I will tell you, I was an engineer and I considered that to be relatively hard. Now, I was a firefighter paramedic for many years when I paid through school. To me, that was hard. But being an engineer was moderately hard. When I moved into architecture and half of my day was talking to people, going to meetings, buying lunches for people on a corporate credit card, playing golf with clients, to me, I couldn't believe people paid me because it was so easy. But it's all about the job you want and the job that's going to make you happy. You love being an engineer? Being an engineer is still a lot easier than many other jobs. And I'll tell you, being an engineer was a lot easier than practicing medicine, and a whole lot less stressful too. Because generally speaking, if you're an engineer and you make a mistake, nobody dies like in medicine. So keep that in the back of your mind. I think they're all great jobs. And I've loved my time in tech after I left healthcare. So Chris, get back to the content. And if you haven't got or downloaded the ebook, please download the ebook, the study guide that we made. It's very comprehensive because we want you to have a great career. Chris, let's go back to the content. We're going to continue our risk reduction and risk management as it pertains to actually using cloud services. So how should we be dealing with cloud services? And it's going to be a process because we're going to have to assess the cloud services. We're going to have to make sure they make sense. And when it comes to any kind of a technology change or architecture, it really needs to come from the business first. So what I'm going to do is I'm going to walk you through the process, and then we're going to talk about each phase. So the real key here, when we want to actually make a change or a change needs to occur in technology, it should be driven by the business, and it needs to be based upon the actual business needs. So you're going to get something called the business request if you're working for the company's IT department. Now, if you're an architect like me, you're already, working with the executives to try to figure out what those business needs actually are. And if you're at a security vendor like a Cisco or a Checkpoint or a Palo Alto, they've already determined they want to do something, and we're going to go help them, and they called us in to help them. So there's usually going to be some form of a business request. Now, if we know we need something, once we figure out what kind of stuff we could possibly use, and that's going to be an extensive process there, we really need to understand the documentation from the cloud provider or any of our vendors that we're dealing with, because everybody's got great applications, everyone's got great products, network things, but each technology piece has strengths and weaknesses, and we need to make sure we select the right one, and we're not going to know that without getting deep and diving deep into the documentation we're dealing with. Plus, we need to know what we're dealing with to reduce risk. So this is really where we're going to review the provider's documentation. I'll also use CP as cloud provider, and I'll use docs. We have to do that, and these should occur in real phases here. The business request first, and long before we ever think about something, obviously we need to speak to multiple vendors to determine what's right, read some documentation, what have you. Now, we don't want to just read the vendor's documentation. We want to read other critical sources of information as well. So, that's going to be your next phase. You're going to really look at external sources of information, external anything you can get, business needs, industry changes. So really start looking for external things. And I'll give you the exact Cloud Security Alliance perspective as they would describe it, but this is typically something you really want to do when you look at a security architecture. Now, after we review things and external sources of information and other things that are going to be out there, now we need to think about our compliance needs. Maybe we're in an industry like healthcare where we have to contend with HIPAA laws. Maybe we're in a payment card industry where we have to comply with PCI DSS. Maybe there's other rules and regulations that we have to map to, so we need to make sure that we can map to these things. So we're going to have to map that to compliance. And, that's going to be our next phase that we're going to go through here. And I'll go in deeper into each phase in a minute. I just want you to understand what we're actually doing here. And then part of that is knowing what kind of data is going to be sensitive and what kind of information can get out. So we typically have to map our data or classify our data. So, but I want to keep it in the format you'd get from the Cloud Security Alliance. So we're going to map to a data classification. And once we get past this, now we're going to determine what kind of compensating controls, what kind of mitigations are we going to use to keep our information secure. And this could be all kinds of things. It could be a firewall, for example, some data loss prevention type tools, an IDS IPS system, an ACL. Realistically speaking, it's something, it could be a control that we can use. And then it may not just be technical controls, but we have to define the controls. And I know that looks pretty ugly. Let me see if I can make the box a little wider. And after we define whatever our controls are going to be, Now we can start looking at and maybe approve a service or disapprove a service or start using these things. But we need a good, clean process like this to actually determine what we're going to use on the cloud. Is it suitable? Is it right for our organization? And we need to do it in a very careful, methodical planning approach. We don't want to ever just assume something. We need to get all the information. So that's, really what we're talking about. So let's talk about the business request. Here's the key. It has to be based upon the business's actual needs. Most technology projects are disasters. 70% are disasters because the business needs this and the tech people do this because there's no one in between. And that's why companies have been hiring so many cloud architects, security architects, AI architects, enterprise architects. It's all that go between aligning the technology teams and the business teams. Now, when it comes to the business request, I need to make it very clear, there's no such thing as the best technology. I'm going to say it again. There's no such thing as the best technology. The optimal technology, the best technology, is going to be the one that best meets the client's needs. Now, when we have 10 different options, each option has their strength and their weaknesses. These are called architectural trade-offs. And we have to determine those trade-offs. And that's really what we're going to be. If I do this, it's going to add this complexity to the system. If I make this choice, it'll add a different level of complexity to the system. And these are the kind of decisions we typically use. So we have to always understand the business process. We always have to understand the business needs. We have to understand the way people work, because we can't lock down something if we don't know how people are doing their job and where their traffic is going from and whose message is going to whom. Now, once we've done that, now we really need to read the cloud provider's documentation, right? We always need to read any vendor's documentation. So we need to read the cloud providers' published security and privacy policies to make sure they align with what we need. We need to review the service level agreements, which basically says if the provider doesn't meet whatever it's stated it's committed to do, they give you some money back, for example. We have to look at the contracts that we have going back and forth with the cloud providers or any other technology provider for that matter, and look at the terms of service, who's responsible for what, who's responsible for what kind of liability. We need to really look at whatever kinds of potential certifications the provider potentially had. They have various security control certifications like ISO 27001 or other third-party validations. So we really want to look at that. Now, we always want to look at external sources of information. Everybody wants to tell you about the product, but what other companies are using the company's products? Are those companies been successful? Does the cloud provider have a history of a whole lot of security incidents or operational incidents, or they had a lot of outages that don't sound right when they explain them? We have to assess the cloud provider's security posture to the best of our abilities, because we're going to put our data center stuff in their data center and they're not secure. We have a problem. So we're typically going to do that. Now, obviously, we have to map to any compliance requirements. And, the good news is most cloud providers are very good at mapping to compliance requirements. And that's why, in many cases, cloud is almost a half easy button for people, even though you may pay for that easy button. So we have to look at cloud providers that might be already ready to go and know how to deal with GDPR or HIPAA or PCI DSS. And by doing so, it makes it easier to verify that it's done, that we've met the regulatory requirements. But we still have to make sure that the cloud providers are meeting these standards as well prior to moving a business that would need to meet a certain standard. Now, for data, we need to know what we're going to protect, right? And how much protection we need. So we're going to have to do a data sensitivity assessment. And that's going to determine what data is sensitive and how sensitive it is and the risk of various types of data being breached, for example. And we need to tailor the standards on how we treat the data based upon the sensitivity of the data. Not all data requires the highest security standards. So we want to match the security standards to the data's sensitivity. And before we just use a service, we want to determine that it's right for us. We're going to approve the service and make sure that we know how to use that inside of our organizations. Now, compensating controls. We have to do this for everything we do. There's a risk, there's a control. There's a risk, there's a control. And we have to determine how to reduce the risk. So we need to think of any extra tools that we need to kind of fill the security gaps. And these could be from the cloud provider, or they could be outside of the cloud provider. For example, we might be dealing with firewalls from Check Point, Cisco, Palo Alto, and Fortinet when dealing with AWS as opposed to using an AWS firewall. But we might be using some of the great AWS services in AWS. So we need to be looking for compensating controls. And the goal is to make sure the data is safe. I mean, that's all we're really trying to do. Or the goal is to make sure the systems are safe of whatever it is we're trying to protect. Now let's talk about the approval process and the decision-making that goes back to that. We have to determine if the cloud provider services are suitable for us and our data. And if they are, we can approve it for whatever meets our criteria. And typically speaking, an organization should have a cloud register or some kind of architectural repository where they're going to document various things like approved services and controls. And the reason organizations need cloud registers and architecture repositories is when you know what the organization has, it's much easier to make changes because you don't have to map everything out when you're changing it. When you know what the system is, when things break, it's easier to fix it. When you know what the system is, you know where the weaknesses are and you know how to add capacity on demand so it scales or whatever's necessary. So you really need to have a good architectural repository. And this is also going to help with compliance as well, because in compliance, you'll be able to check all these things, and the better your documentation is, the better things you'll find. So when it comes to compliance and audit, let's talk about that a little bit. So there are things that need to be audited. There are standards that need to be audited, and certain businesses that have to meet a certain industry regulation may be subject to various audits. And if we talk about the definition of compliance, it's really the adherence to any kind of international policy, law, regulation, industry standard, or the such. So if you have to do this and you do it, you're compliant. If you have to do this and you don't do it, you're non-compliant. And the goal behind this is to give really good, strong, ethical standards to organizations. And there could be lots of different places where you can get these kinds of requirements or various audit things. And there are certain frameworks, honestly, that you could use and say, well, this is probably better for my data security as well. So we might be looking for national and international laws and regulations to determine what we need to comply with. For example, we might be dealing with industry standards like PCI DSS. We could be dealing with contracts from one provider to talk to another provider or two companies to connect. And there are certain level of things that you'd have to agree to on both sides as well. So, we're going to be assessing and auditing to make sure the organizations that we're dealing with meet a certain level of standards. Now, I know I discussed this before, but I want to bring it back again. Jurisdictions, it can get icky and sticky in the cloud. Because cloud deployments can often span many legal jurisdictions at the same time in regulatory jurisdictions. And, this could be based upon the location of the cloud provider, the location of the cloud customers, the location of where the data might be, the location of where the data could or would be stored. So this could get fairly complicated. So we have to make sure we understand this, and we need to make sure that we understand the implications. For example, a breach notification might be required in the operating country, even if the data is not even in that country. So it gets more complicated in the cloud, and this is one of the reasons we have to be careful with our contracts as we're dealing with things. Now, there are some laws and regulations and examples of them, and I'll go through some. Many of these are related to cloud and non-cloud, so they've been around for a long period of time. So there is the COPPA, the COPPA regulation, which is to protect children's online privacy. There is this CCPA, Charlie, Papa, Alpha, and that's a California law out there with really strict requirements on data handling and protection. Brazil has this Lima, Golf, Papa, Delta standard. And that's fairly similar to the GDPR, where it emphasizes data context, individual rights, penalties, and violations. And there are other national laws out there. There's the Japan Act for the protection of personal information, which has some regulations related to data collection, data use, and even cross-border use. There's the Australian Policy Act, which focuses on consent, data accuracy, and disclosure. In the U.S., we had the Gramm-Leach-Bliley Act, which requires financial institutions to safeguard consumer information. In healthcare in the U.S., we have HIPAA, or the Health Information Portability and Accountability Act, which protects medical privacy regulations. In the EU, for example, you have the Digital Operational Resilience Act, or DORA, and that ensures regulations for critical financial infrastructures in the cloud. There is an AI Act in the EU that establishes trustworthiness for AI systems. There is a Network and Information Systems Directive that strengthens cybersecurity policies for EU services. So you can actually, there's even a European Banking Authority guideline that really regulates outstanding arrangements for European financial institutions, or outsourcing regulations. So, there's a lot of these, and we have to be aware of them, especially if our data or locations or systems are going to be in these organizations. China has a cybersecurity law too that protects online infrastructure and data, and it grants authorities the power to actually monitor and regulate cyberspace. And of course, you'll hear constantly the PCI DSS standard, and that's going to be a global standard for securing financial data and protecting cardholder information. So when we talk about compliance in the cloud, we have to think about secure storage. And how do we do that? We use encryption and safeguards. We protect our data at rest, our data in transport, and we need to make sure that we delete data securely when we're no longer using it. We have to follow due care, which means we have to follow industry best practices on security standards and continually protect data from threats. And we need to keep an audit trail too. We need to keep detailed records of data processing to demonstrate the compliance and support of everything. So we're constantly looking for things. So when we start looking for these environments, we need to understand what we're doing. We're really trying to protect the environment, protect the organization. Okay, we're going to talk about some standards. Now, there are international standards for information security management systems, and they really focus on securing information through people, process, IT systems, and risk management. And this is going to be applicable to organizations of all sizes, and it's used for systematic and cost-effective security controls. So we have something called system and operational controls, and these were developed by the American Institute of CPAs. And this covers 5 trust service criteria that include security, availability, processing integrity, confidentiality, and privacy. And it's going to be essential for software as a service companies and tech companies to really protect customer data through detailed controls. We also have the security, trust, assurance, and risk, the STAR. And that is a cloud security registry, and it really showcases cloud providers' adherence to standards. It's enhanced typically with cloud-specific controls and what you would call the cloud controls matrix. Now, let's talk about inheriting compliance. And what does this mean? So if we talk about inheritance, a customer will inherit the cloud service provider's compliance controls. So if we're dealing with a client that needs PCI DSS, they're inheriting the compliance controls from the cloud. That's why it's often considered to be the easy button in parts of it. But the customer still has a big responsibility here, because while the infrastructure, the underlying infrastructure of the cloud is PCI DSS compliant, the customer still has to assure that their applications and configurations are going to meet the PCI DSS standard, which goes back to that shared responsibility model and all the challenges of dealing with two parties. And in many cases, both the cloud providers and are going to have to undergo audits, and that's the only way you're going to know about how they actually adhere to certain things, because you can't just walk in their data centers and deal with it. So let's talk about what audits are artifacts of compliance. And artifacts are typically something substantial. It could be a software artifact where it's a piece of software. It could be an architectural artifact, which is a piece of documentation. So let's talk about artifacts of compliance. Now, these could be logs or any kind of documentation and records that provide evidence to support compliance activities during an audit. Now, customers must ensure that they have the necessary artifacts that'll fill any gaps that might be by the cloud provider to prove that they're compliant. So I'll talk about some example of compliance artifacts. We've got obviously audit logs, any kind of detailed record of an event or an action or a change in the cloud environment. Maybe some activity reporting, which might be summaries of user activities across platforms. We could be dealing with system configuration details, something that would document network settings, access controls, system settings, what have you. We might even want to provide change management records, which is basically every time we made a change, updated an operating system, modified, changed the protection of the system. So that might be something we want to talk about. Now, when it comes to governance, risk, and compliance, there's also non-tech. It's not all about tech. There's non-technical tools as well. We need to create some very clear documentation of responsibilities in our contracts. We need repositories and risk registers and service registers. And we need really good frameworks and processes that are going to be tailored to our business's needs. And of course, we want to use as many good technical tools as we can to automate labor-intensive tasks to improve overall efficiency. Okay, well, we are back. So we'll see if there's any questions. If you have some questions, pop it in the chat box while I wait a minute or two to see if there's any questions. I want to let everybody know that we have a free e-guide that goes along with this. It is a very comprehensive guide that my team made based upon the training I created for this to help you with the exam. Please sign up for it. It'll be emailed to you within 15 minutes upon completing our form, and it's all free. I also want to remind everybody that on Thursday this week at 11 a.m., we're going to talk about how to become a security architect. We'll go over what is a security architect. We'll talk about everything we do as security architects, and we'll talk about all the skills you need to learn to be hired. And then we'll spend upwards of 60 to 90 minutes answering any question you may actually have, live and free on Zoom. I also want to let you know that every Wednesday between 2 and 4 p.m., I come on live and free to answer any type of tech career questions. Maybe you want to become a network engineer or a security engineer or a network architect or a cloud architect or an AI architect or a security architect or any of these things. And we'll come and do what we can to help get you to your career goals and answer your questions. And they're all free. So sign up for one of them. I'll look and wait about 30 more seconds to see if there are any questions. And if there are not, we'll get back to the content. But while we wait those 30 seconds to see, give me a hashtag CCSK so that I know they are awake, you're alert, and oriented. We're going to get involved in some fun stuff today. We'll start to actually get involved in looking at domains and looking at organizational hierarchy and the cloud, things like AWS organizations. We'll have many, many more fun security things to talk about. Well, at least to me, it's fun. I love security, though. So for me, it's all kinds of fun. So I don't see any questions. So Chris, let's get back to the content. Now we're going to discuss domain 4 of the CCSK exam, which is going to be organization management. And many organizations are using many clouds. They're using multiple clouds. But the key with some type of domain management is to really get us to a better level of security and be able to come up with similar policies across our entire management. We're trying to find a way to build some control and some governance into what we're doing and to make sure things don't leak from one environment to another. So that's what we're talking about with regards to organizational management and organizational hierarchy. So the cloud providers themselves have the ability to let us chop our account into maybe little mini accounts and keep them separate for each other. And by doing so, we can make people talk to each other, parts of the accounts talk to each other when we need to, not talk to each other when we don't want to, and really enhance security. So it enables us to really create a segregation among our environment to reduce something that's called reduce the blast radius. So if we separated the finance department from the HR department, if something happened in finance, hopefully it wouldn't hurt the HR department. And the cloud providers all have their own hierarchical models that we'll actually talk about. And we'll talk about those that are used by AWS. We'll talk about those that are used by Azure. And of course, we'll talk about those that are used in Google Cloud. Understand all cloud providers have the ability to do this. We're just going to cover the big three here. But the goal here is to create a standardized approach to really figure out how you would implement an organizational structure, especially across multiple clouds, because everybody is multi-cloud in today's world. So that's where we're going to talk about the other organizations. So typically speaking, we'll have a few definitions. We'll typically define on a standards basis that the organization is going to be the highest level structure inside of an organization. Now we may have a group, which could be a collection of deployments, and a deployment, typically speaking, would be an isolated environment inside of a cloud service provider. I'm going to say that again. An organization typically is going to be the highest level that we're dealing with. We may have groups, which are collections of deployments, and a deployment is basically going to be an isolated environment in a cloud service provider, like a VPC or a VNet, for example. Now, all the providers have their own version of some structure. For example, AWS, you may hear of organization at the top level. You may hear at the group level organization units, and at the deployment level, you may hear accounts. Google, what you may see is they may have organizations just like AWS. And then instead of at the group level, they have folders, and at the deployment level, they have projects. Or Azure typically uses a tenant at the organization level, a management group at the group level, and a subscription at the deployment level. But we're going to walk through the individual ones, and I'm going to draw some graphics for you along the way. I'm first going to show the AWS resource hierarchy so you can actually see it. So in this particular environment, notice this, you'll see the structure. AWS uses a 4-level hierarchy. At the top, we have the organization, then we have the organizational unit, then we have the account, and then we actually have the actual resources inside that account, the things that somebody would access. And from the management perspective, AWS uses something called service control policies to manage permissions across organizational units. These are basically IAM policies that go across organizational units. And basically what happens is we can have resources that could be grouped into something called a resource group. And we could do that based upon, say, a resource tag or relationship of certain systems. Now, there's a lot of flexibility in this hierarchy. It's less rigid compared to Azure and Google, and it allows for a fairly easy deployment of a multi-cloud approach that can enhance the isolation in between different parts that you're actually dealing with. And at the same time, while it enhances isolation, the opposite side of it is it's going to complicate permissions. So because you're getting out of a standard single organization where you've got your more role-based access control, now you're going across organizations, so you may have different policies. So that is going to be the complexity there. Now, so if we looked at, we've seen what that actually looks like, I'll show you another graphic that may help you perceive that this graphic from Amazon's website, and you can see the root of the organization, and you can see how they have their organizational units, and then you can see how they have accounts underneath each account. And what they don't show is the resources in each account. So you can see this in this Amazon graphic here. At the top, you'll see your root. And then you'll see your organizational units that are coming out of your main root account. Then you'll see your member accounts, and then under there you would typically have your resources. So that's going to give you a perspective of the AWS. There's a graphic we drew, and then you can see the way AWS would represent that. Whatever will be easier for you to understand. Now, after we get through AWS, let's talk about the others. So let's talk about resource hierarchy in the Google Cloud Platform, for example. Now, Google has a 4-level hierarchy. Fairly similar to AWS, but slightly different. At the top, we're going to have Google is going to have something called the organization. Directly under the organization, you're going to have the folder, and under the folder, you're going to have a project, and then you're going to have resources. So if we really look at this, what are we dealing with? Folders can group projects, and that allows for additional organization. And projects are going to be the primary container for where we're going to put our resources. And permissions will be managed through IAM policies that can be inherited from higher levels. So ownership here is going to be when the organization resource exists. Projects are owned by it rather than an individual user. And by doing this, it's going to enhance the lifecycle management and the security of the overall system. So that's typically what we're talking about from the Google perspective over here. Now, there's all kinds of hierarchy in all these types of environments that you can see. Maybe I'll show you another version. This version would be drawn by, say, Google. Maybe this will make it a little easier for you to see. This is the way they would represent it. You can see the source of this graphic, where they start at the organization level. They have the company, and for a folder, they have various departments, which would make sense, like a finance department versus a sales department. And underneath that, you have the project, and underneath the project, you have the resources. And whether it be a virtual machine like a compute engine instance, or an app virtualization like an app engine, or your storage environment, that would be the resource hierarchy. Now let's talk about the resource hierarchy in Microsoft Azure. Now, Azure uses a slightly different resource hierarchy to put that into context. And Azure's hierarchy consists of 5 levels. At the top level, we have the root or the AAD tenant, and that's going to be at the top. Underneath that, you'll see we have management groups. Underneath that, we'll have subscriptions. Underneath that, we'll have resource groups. And underneath that, we'll have resources. So, realistically speaking, if you look at this, the subscription is going to be a container for the resources. And the resource groups really just enable some kind of a management based on a life cycle or the project itself. And what's going on here is for the most part, we're using Azure's role-based access control model, and it's going to facilitate these permission inheritance from higher levels to lower levels. So if you're familiar with permission inheritance in Windows, it's going to feel very similar like that. And that's going to make it fairly easy to manage access control. The alignment here is that the structure is designed to align closely with an enterprise's organizational structure, and therefore kind of simplify resource management and the such. So that's why, Azure has their hierarchy. And if you noticed, all the cloud providers are doing this, and they're doing it to make it easy. You can see visually how, bear with me one second, how Azure is representing this as well. And you can see they represent it on their site. You can see the source of this. At the top, we have that tenant root group. And then you can see how underneath that, we've got our management groups. And then underneath that, you can see where the subscriptions are. So all cloud providers have it. And the point is, it's separate our environment. It's going to create an environment where we can reduce the blast radius. So these are basically what we're talking about. All the cloud providers have some version of this. And if you can see, maybe I'll move this over. Bear with me a second to try to make this look a little easier for you to see. You can see AWS, Google, and Azure, they're pretty similar. Only the names have changed. And what you're going to notice in cloud computing, for the most part, most cloud providers are offering, for the most part, the same different names. And that's the basis of most cloud certifications, is just teaching people the names and then how to configure these things. So these is going to be for strategic reasons. We're trying to reduce the impact of a breach. So if somebody breaches and gets into one thing and they don't get into another, the overall impact to the organization or the business is less. We can also ensure compliance with various service limits and various things in various accounts this way. It's going to enable some type of a logical separation of our technology stacks, and it's going to simplify resource management, and it's going to give us a structured hierarchy that we can actually use inside of our organization. So there's a lot of benefits from doing this for the organization, putting in this kind of policy. And by using this type of environment, by using policies, by using groups, by using IAM, by using shared services, we can enhance our security. We can make it logical, and we can make it easy to manage. Now, one thing that'll help reduce our risk is we can use consistent deployments. So whether we're using landing zones or account factories or pre-configured templates, to automate an account setup. Anytime we can automate things, if we know how to automate it correctly, we're going to reduce incidents. And this is going to be configurations of operating systems, infrastructure as code, to launch cloud resources. Anytime we can get consistent, and maybe we can even lock down certain gold standards, that puts us into an environment. So realistically, you can see it's not that different than anything we would do to organize a business now when we're building a hierarchy inside of an environment. So let's discuss applying our security controls at the organization or group level, and not just at the individual deployment level. What's the point? The goal is to keep our risks under control. So we're on the cloud. It's so easy to deploy systems on the cloud. If we come up with a structured approach, we don't just start putting stuff on the cloud. The goal here is to manage the cloud footprint effectively and still support business goals. And, there are going to be tools from the cloud providers that are going to give us features for governance and security beyond traditional things to think about, like network or application security. And realistically speaking, a good starting point, long before we think of some of the other things we'll think about, is really creating a good tenant structure and control where things are actually going. Okay, now how would we create or build our hierarchy inside of a provider? Well, we have to think about how we want to structure it. One approach is to base it based upon business units. So if we have a company with multiple business units, we create our hierarchy but where business units are segregated, which is quite possible. Another possibility we could do based upon, the geography. We could have Europe here, we could have the Middle East here, we could have Africa here, we could have Asia here, we could have Pacific Rim over here, we could have North America here, we could have South America. So we could use some type of geography if used. We could also create a resource hierarchy like environment-based, like production environment, test environment, staging environment. So there's a lot of ways that we can come up with a hierarchy, but we have to plan that hierarchy and make sure that it's going to be manageable for us to use. See, the goal here is to keep risks under control and keep things simple. The cloud providers may give us some tools for governance beyond what we might normally get, and this might be great, but we need a clear structure. So one thing for sure is some best practices to talk about is we want to minimize root access. We want to limit the highest level privileges, the things that can room out on the most risk or destruction to the business, to only those that actually need it. So we're going to have to minimize root access. We're going to restrict deployment creation. So we don't just want anybody in our company deploying big cloud computing environments and spending a lot of money. We want to limit it to a certain number of people. So we're going to restrict who can do that and provide some structure around that. Now, we may also want to try things or sandbox them and before we actually put them into production. And there's lots of opportunities where we can do things like that that we can actually talk about in the cloud providers environments that exist. Things like landing zones, account factories, what have you. So we have to think about the policies that we're dealing with. We can apply an organization-wide policy, generally speaking. And that's going to be to all departments inside of that organization. So if we go back to that top level example we talked about where you could have an organization and multiple organizational type units, so to speak, if we apply it organization wide, it's going to apply to everybody. Now, if we apply it at that group level, or an AWS would use the organizational unit level, we could make it just to a specific set of people inside of that group. Or we could even create a policy just for a particular deployment, additional controls on a specific deployment. So providing these governance controls in cloud computing really makes it a lot easier to do some of the things that we really want to do. So we have to determine what we're going to use. So we might enable or disable certain services on the platform for people to be able to use them. We may block unauthorized API calls. We may disable regions of the cloud provider where we're not going to be working, or we don't want our data to be moving over, for example, for data residency purposes. We may want to be setting conditions, for example. Only API calls are allowed from an authorized IP address, for example. We might be doing a lot of things. So we want to prevent people from restricting access to critical services by mistake. So we want to put in some good controls to make sure things are there. And, we want to have some control over the policies so they're not getting modified by people that are not supposed to be able to modify them. So we're looking to get some consistency across deployments. And, this is going to get harder across cloud, but there are things that can make life easier. So if we use centralized identity and access management across our deployments, it's going to make things fairly consistent and easy. If we can come up with some form of centralized logging and telemetry where all of our logs are going to come in our SIEM systems, this is also a great thing. Again, with multi-cloud, we might have to use industrial tools and pulling them all to a single location for centralized monitoring. It may not be so easy, because we may not be able to use individual cloud providers monitoring tools. We may need to use more industrial packages that work across all clouds. We're going to need to use some threat detection services, and we want them to be monitoring activities for unauthorized behaviors as well. But doing things like this, we've got some centralized cost management, and here's what we're talking about in the benefits. So generally speaking, the more you buy, the greater the discount you can negotiate, right? So if we had 10 different accounts, each account might be a little bit at a discount, but if we have one big account, we get a bigger discount. So a lot of what we're dealing with this concept of shared services and organizations and organizational units is about, okay, company A is spending this much, therefore they qualify for this discount, but they segmented their thing into what looks like mini accounts to keep them much more secure. So I kind of hope this can help this make sense. We may want to think about account factories that can automate the setup, configuration, these kinds of things that we're dealing with. They're trying to make it better. Now, understand a lot of organizations are multi-cloud. And a lot of these things become much more challenging. So now we have to think about managing organizations consistently across multiple clouds and our data centers, which gets a little more complicated. Now, with regards to IAM, we're not going to be able to use a single cloud provider's IAM. We're going to need some kind of centralized IAM that's federated with all of our clouds. Now, when it comes to securing a multi-cloud or a hybrid cloud, we're going to have to segment to some degree our cloud providers, and maybe we run firewalls and other things in between our firewalls, in between our cloud providers, for example, and firewalls between our data center and our cloud, and we put other controls. We're going to have to use a lot of tools to manage the security, to manage the complexity in these types of environments, because for the most part, everything is multi-cloud or hybrid multi-cloud. Now, strong identity and access management systems are going to be critical. Network security to protect across organizations, clouds, or cloud providers is going to be critical, and we're going to need different controls. So the cloud providers controls we're not going to typically be able to use. We're going to need different type things. We're going to have to plan exactly where we do things, management, subnets, and all types of things. But it's still completely possible. It's still completely feasible. And we do it with most environments. I mean, let's face it, multi-cloud happens for a lot of reasons. One company buys another company. One company is on Azure, one company is on AWS, and poof, they're multi-cloud. Multi-cloud could be a company wants higher availability, so they put half in 2 different clouds. Multi-cloud could be for so many reasons. So, kind of keep that in the back of your mind. So, primary, secondary, full multi-cloud. So for the most part, everybody's there, and each organization has their own unique features. So it's going to make it a little more challenging. So you're going to have to be much more structured in the multi-cloud environment. Now, there's a lot of container and cloud agnostic misconceptions out there. Containers improve workload portability, but they don't eliminate the need for infrastructure or infrastructure orchestration management. People forget that containers, there needs to be a container orchestration platform like Kubernetes. Shared services, databases, message queues are not very portable. So what does this mean in a multi-cloud environment? Don't use an Amazon SQS. Don't use somebody else's proprietary thing. Use Apache Kafka or something that's suitable in all environments, and you won't have problems. So there's some theory and concern that a cloud agnostic approach might lose some of the economic security and operational benefits of cloud provider-specific platform as a service services. Potentially. But at the same time, when you do things and you're using bigger and more industrial tools, you may actually get greater security as well. So the reality is multi-cloud adoption is going to be there everywhere. It's out of necessities. Sometimes it's strategic planning. Sometimes it's one company bought another, but it's there and we have to constrain with it. Now, a little bit about software as a service with regards to organizational management. Software as a service providers are often used because the software is ready to go and you just basically use it. But we have to manage software as a service security as well. We have to check the cloud providers or the SaaS provider security. We have to check their compliance before allowing them to handle any of our data. We need to keep centralized records of all approved software as a service providers. We need really strong business reasons to adopt new SaaS providers because realistically speaking, trying to manage the complexity and security across many software as a service providers can get fairly risky. We really need to manage those data flows between SaaS and other applications to maintain control. Lots of tools for software as a service management. Lots of tools to help us with the IAM across all these accounts, cloud providers, what have you. Well, accounts are easy, but cloud providers and multi-clouds, hybrid multi-cloud. So a lot of what we're going to be dealing is with federated identity management. And typically, we could be dealing with a federated broker, like an identity broker, like a Google or Yahoo, that an organization could federate to use their information. They could be federating to an Active Directory servers that are on campus. But typically, federation is where we take one environment, they trust another environment. For example, if I wanted to log into a system at AWS, the AWS system would ask the Active Directory system on premise. Active Directory would say yes, and I'd be allowed into AWS, that type of environment. So there's going to be a lot of federated identity access management. We're typically going to be dealing with cloud access security brokers who are going to monitor and control this type of identity strategy across multiple software as a service providers and cloud providers in a very convenient sort of manner. So there's lots of things that we can be looking for. So we've finished this section, and we're going to get into some much more fun of identity and access management next. Okay, so we are back. We are here to answer a few questions if anyone has. And then we have a good 35-minute additional session. Normally, I don't record things ahead of time, but I've been having some back issues, which I'm getting addressed in next month, thankfully. But so I wanted to make sure if I had a good back day and a bad back day, we'd be here and we're around. So feel free to ask some questions. I'll answer them, and then we'll go back to it. Now, Chris, I think there was a couple questions good from the last time. So with our conversation about governance, would I mention NIST 800-171 or 53 and the implications if not being ready for CMCC compliance, since it's supposed to be required in all federal contracts by April? So I guess we'll see if that still goes through, because it looks like our government is in all kinds of dynamic change, but let's work on the assumption that it actually does. So if we really think about it, it's not going to have that much of an impact to a bigger organization, because level one, what they tried was really basic hygiene practices. We're getting a little closer with CMMC 2.0. We've got that alignment with the NIST 800-171. Now, on the assessment side, when we're dealing with the basics, we can actually do a self-assessment, which is probably never going to be good enough, and that's new here. But for anything that's going to be sensitive, level 2 or level 3, they're typically going to need some independent assessments. So, we're in this kind of environment. We're looking at it. Regulations are subject to change. The reality is, if you're going to design a good security architecture, it's really going to exceed all these guidelines anyway. In fact, in a lot of security architectures I look for, when people say which regulations, it's like, well, obviously exceed all these regulations out there, because what we really need to is achieve this, and this is the level of protection we need, and it's far greater than any of these things. But it will make it harder for smaller businesses to compete effectively, because it's going to be a more costly process, especially if they're dealing with more sensitive data. Now, should they have had that level of security anyway? Yeah, so it really shouldn't make a change to anybody who's actually dealing with security in a modern approach to it. So I hope that kind of helps. Chris, if there's another question, we can bring it in. Would cloud service providers have to meet FedRAMP standards? So the answer is yes, but all cloud providers easily meet FedRAMP standards and can easily get past that. So that's not necessarily going to be a challenge that needs to be done. Good questions. You're thinking it through. I love it. Is there a natural format that I follow relative to the guide? Well, yes. So what I typically do is I make what everybody would call chicken notes or cat notes, where I put a couple words on a slide so I know what to talk about. And then I talk about what I know is required in the certification. And then I usually add a lot of additional context, because there's a lot of things in every certification that are partial truths, and I try to give you the full truth. So yes, my team actually made the study guide based upon the chicken scratch slides or chicken note slides that I actually make. So yes, they could actually be there, and they, for the most part, do follow each other. I will often talk about or whiteboard things that are not in my slides if they're necessary to be for comprehensive. But yes, there is a logical flow, definitely. but not everything in the book will. I may talk about more things that are in that book because I want you to really be prepared. I want to remind everyone that see if anybody else has any questions. But if not, on Thursday, we have a how to get your first security architect job webinar this week. It's going to be at 11 to 1. But normally 1 to 3, but this week will be at 11 to 1, so we can have fun with our free security boot camp in the afternoon. I love doing these things. So sign up for that. My team will provide the link. We get to meet. It's on Zoom. We can have a face-to-face conversation. We'll go over the role, what we do, and the skills you need. And it's free, so join you. I look forward to meeting you there. Also, if you just joined us and you haven't gotten the companion CCSK study guide, it's a pretty comprehensive 400-page study guide my team made to help you with this exam. I recommend you go download it. On every Tuesday from 2 to 4 p.m. Eastern, I do a free question and answer session, directly speaking, on YouTube to kind of help people with their career goals. So I don't really see any more questions popping in the chat box yet. So give me a hashtag CCSK. And Chris, let's get back to the content. I want everybody to have a fun time and learn about as much about cybersecurity and cloud security as we can do in this week of free training. Now we're going into domain 5 for the CCSK exam preparation, which is going to be identity and access management. I'm going to get a little bit more detailed here than you would actually need for the exam. And the reason I want to do this is with cloud computing and its soft perimeters compared to the hard perimeters we used to have, IAM is going to become one of the more critical aspects of security in the modern world, especially cloud computing. So I'm going to give you extra information here, almost to the level of the CISSP exam. And then I'm going to give you the CCSK materials all combined in this chapter. So what we're really talking about when it comes to identity and access management is really controlling access. Because we don't want the wrong people to access the systems. We don't want people to access parts of the systems they don't necessarily need to access. So identity and access management is going to be about determining who the user is, or who they claim to be, determining what they're allowed to do, and then keeping track of what they've done. So we'll begin by talking about controlling assets to assets, which is really what IAM is all about. So organizations will have assets of all kinds. We have to control who can actually access them. The same way you would protect money in a safe, you would protect other assets like a secret formula to something, for example. So a company may have an asset in the form of information, which could be data that's either in its databases, its storage, or anywhere else. They could have systems, which could be whether it be routers, switches, network servers, and everything else that are critical to their business. And if they're down, the business will suffer harm. Or they could even be devices. You don't want people to access a device or a technology or whatever it is. Maybe you don't want someone stealing an airplane, for example. That's a device. But you might also want not people destroying technology that you have or components of it. So it's about determining who can access what, and then what are they allowed to do and keeping track. And we may have to control access to a facility. A physical location, for example, we'll need to protect. We may also have to control who can access an application and what they can even do in that application. So this is really where we're going in the world of identity and access management, the things we'll be discussing. So if you're going to determine some form of security, who gets what security, right? So if you had a person that needed to walk into a building, and let's say it's a high security building, because it's the same thing for a high security environment. If Mr. Jane Smith, or if Miss Jane Smith is allowed in, and it's a secure building, what do we have to do? We have to find some way to see that Jane Smith, who's allowed in the building, is actually the Jane Smith that's actually in the building. So in a high security building, you may walk in, and they may look at you. They may make you sign in a book. They may take your driver's license and driver's license number. They're identifying you. Now, that identification is typically called authentication. And authentication, identification, it's all about really determining, is Jane Smith really Jane Smith? Because we don't want someone pretending to be Jane Smith getting Jane Smith's access, for example. And it could also be doing the same thing for a device. Is this a legitimate device or on our network that's allowed to talk to other devices, or is this not a legitimate device pretending to be a legitimate device? And that's really about what authentication is. Now, there's going to be a lot of approaches to determine if someone is who they claim to be. We'll talk about that. Now, I want to talk into the concept of subjects and objects. All in all, a subject is going to be, say, a person, and an object is going to be something they're going to be working with. So when we talk about an overview of access control, it's going to go beyond just managing user file or user service relationships. We have to focus on the understanding between various subjects and objects. So a subject is an active entity that's going to work with an object. So the subject could be you, and the object could be something you're working with on the system. And a subject can receive information from the object or provide information to an object. And examples would be a user, could be a program or a process. And anyway, authorized subjects can modify an object. But let's bring it back to the building. You're allowed into the building, you're allowed to go to the kitchen, and you're allowed to actually use the pots and pans in the kitchen. That's a level of access control. You are the subject, and the object is that kitchen thing that you might need to use. Now, if we go back to object, which is going to be the next concept, that's going to be the passive entity that's providing the information to the subject itself. So the database could be the object that the subject's allowed to use, for example. It could be a computer that the person or the subject is allowed to use, or a program. And realistically speaking, you can almost think of the object in some ways as the target of the subject. The subject uses that. So let's talk about an organization. And somewhere along the lines, we need to register and prove and establish identities. So we have to determine that people are who they claim to be. So when we hire a new employee, ideally during the hiring process, we've already checked this documentation. Identity proofing is if someone pretends to be Mike Gibbs, for example, and they're going in, check this passport, check the driver's license, prove that it is actually Mike Gibbs. Because if not, somebody's pretending to be me, that's somewhere else. And, this is how when a new company hires people, they typically ask you to fill out and verify that you are who you are. Now, many companies also background check you, fingerprint check you, and other ways to prove that you are also who you are. So typically speaking, after, we authenticate the documents or whatever it is that the person or the device is proving that they're real, we're typically going to have to create some kind of account for them. And for the user to actually use these systems. And many organizations use all kinds of methods to determine if the user is who they claim to be. And we'll get into multiple things, but you could have a username and password to prove that you are you. Not real effective. We could use your iris, the colored part of your eye, to determine who you are. We could look at the retina, the back part of the eye, to determine who you are. We could use a fingerprint, for example. You can have a token card. So there's lots of ways we can do this. But ultimately speaking, we're going to have to know who the user actually is. And we're going to have to find some type of it. We could also do something called knowledge-based authentication. Now, I'm going through various authentications, but I want you to understand what is a knowledge-based authentication. Have you ever tried to get a credit card or something, and all of a sudden they put you on the phone and they ask you what your mortgage was or which addresses you used to live at, and they ask you funny bills about bills that were 20 years ago that you don't even remember what you pay? Well, they're trying to use knowledge to prove that you are. So that's a type of thing that could be done identity proofing. Now, when we get asked to get a credit card or something and they ask us questions that we may not even remember, that's one set of things. But if we're dealing with an organization, we can deal with, specific questions and answers and ways that we can prove identities. So authentication is determining who you claim to be. Now we're going to talk a little bit more about authorization, which is what you're allowed to do. So the authentication determines what you are, and then it's the authorization that determines how you do. What does this mean? We have a person who claims to be the CEO. They've proved that they're the CEO, and now they get access to CEO stuff. But the next person tries to access the system, and they're a secretary or an assistant who doesn't work for the CEO. They try to access the CEO stuff, and they're denied. So we can't know what to deny or not deny or authorize until we know who you are. So that's why we had to always talk about authentication, because I have to first determine who we're dealing with, and then we can determine their access controls. Now, the last component of this IAM strategy is going to be accounting. And it's really auditing, logging, monitoring. I don't care what you call it, but it's the ability to go back and audit. And actually, there's a slight difference, but to go back and audit and see Sally changed this, Billy changed this, George changed this, Aguilo changed this, O'Nicolaus changed this. And in the end of the day, that's how we can figure out what happened and things when they went wrong. So if we don't have any logs and we don't have any monitoring, there's nothing to audit later. So a good IAM system will give us a lot of data after the fact. So we're going to be able to see who made what changes, who performed what action, where it occurred, and even when it occurred, and the nature of the action. And accounting's all about audit trails. And these audit trails are going to be coming from logs, and they're going to help us reconstruct events after the fact, and it's going to give us a lot of information. And we'll talk more about SIEM systems later. So if we think about accountability is going to hinge on effective identification of the person or notification, and as well as authorization. We need the combination together, because if different users are identified and authenticated, we should have mechanisms and audit trails that we can track their activity after the fact to make sure that people didn't try to do things that they were not supposed to do. Okay, so let's talk about determining who you are or authenticating you or who you claim to be. So there's a lot of options we can use here. We can use something you know, and this is something that's pretty common. Enter your username and password. Enter your PIN number. Enter the passphrase that you created. And if you ever look at old references, you may hear this called type 1 authentication. Now, you can also have something that you have. And something that you have could be like your ATM card, where you plug it into a cash machine. Now, you may also note that when you plug your ATM card into a cash machine, they ask for a PIN number. And that's a combination of something you have, like the card, and something you know. So that's going to be two-factor authentication. And we've been using two-factor authentication for a long period of time. But we can have something you have. Smart card, hardware token, memory. It could even be a USB drive if we wanted. We can set that up that way. But that's going to be what you used to call type 2 authentication. Now, the next type of authentication we have is something you are. Now, this is going to identify you based upon you. So it could be a face scan, a retina pattern, an iris pattern, a palm scan, a fingerprint. So that's going to be you, something you are. Now, the question becomes is, how many levels of authentication is enough? Do we use a single one, or do we use multiple? Well, if we just use a single form of authentication, like a username and password, it's relatively weak. It gets a lot stronger if we use a retina, for example. But having multiple forms of authentication is going to enhance things greatly. For example, imagine if we used a fingerprint and something happened to the person's finger. Or could it, for example, we might want to have a backup. That could change one thing as a backup form of authentication. We might also want to think of what the criminal would actually have to do in order to be able to win. So if it's a face scan that was used, for example, does the person really need to be awake and alive for the criminal? But if it was a face scan and a passphrase at the same time, which is multi-factor authentication, criminals it would be harder for the criminals to execute the act. Now, anything is possible. So sometimes you have to think like a criminal. How would the criminal attack the system? How would they break the system? And as you start thinking about the faults in every single thing, you'll start realizing why you probably need more than one-factor authentication to really determine people who they claim to be. So let's talk about the strengths of these authentication types. Implementation-wise, something you know is going to be the weakest, while something you are is going to be the strongest. Passwords are going to be the weakest, and biometrics are typically going to be the strongest. However, some biometric factors, can still be bypassed by attackers. And that's one of the things we need to be concerned about. Can, for example, we pull a fingerprint off of a glass or off of a piece of candy or something like that and reproduce that fingerprint, which is a possibility. If somebody used voice as a biometric type of authentication, could AI replicate that voice? Could a criminal take a person who was knocked out and put their fingerprint up to a scan while the person was still sleeping because the criminals knocked him out as part of the process. Thankfully, the person's still okay, but they could move his fingerprint there or her fingerprint there. So you always have to think about all the scenarios. And as you think of all the scenarios, it becomes clear in many cases that, the stronger you get, the better, but maybe you need more than one. So something you are is going to identify you based upon something. So there's a lot of things that we can typically use. So kind of keep that in the back of your mind that we could use for that. Now, something you aren't is something we can also think of. So, if something is not what it's supposed to be. For example, if we have a user and the user, and we've authenticated their device and their device is only supposed to come from a certain IP address. If that's not them that's actually accessing the system, the same device and the same IP address, for example, maybe this looks like something you are not. And then maybe we need something else that we could possibly deal with, because this is not a foolproof system, something you aren't, but it can be integrated into other things, which we'll talk about later, which is where it really gets interesting. So let's talk about context-aware authentication, and with that, and this is going to be a little different. So context-aware authentication is going to be really great in today's modern world, and context-aware starts looking at multiple factors. So if Mike is supposed to be in his house in Port St. Lucie, and Mike only accesses the system from his house in Port St. Lucie, but all of a sudden Mike tries to access the system from San Jose, California, well, that's a concern. Maybe send Mike an additional challenge, like a multi-factor authentication challenge, or maybe deny that Mike. So context-aware is going to look at many factors, and good context-aware IAM systems are, realistically speaking, going to have some AI, and they're going to be looking for behavioral analysis, and they're going to be proactive at protecting the system. Same thing with mobile devices. So, we can have a mobile device that's allowed to access the system, and maybe it's allowed to access the system from 9 a.m. to 5 p.m., for example, but otherwise it's not. So kind of keep that in the back of your mind. If users are coming in after hours and they're not allowed to come in after hours, then maybe something's wrong. So there's some good mobile device management systems that can check and make sure certain software exists on mobile devices and take them and remote wipe them and all kinds of cool things to enhance security. But context-aware IAM is going to be a really big a benefit to something that we have. Now, a password authentication, that shouldn't surprise anybody. It's the most common form of authentication in the world. It's relatively static, and typically speaking, we can keep a password for about 60 days, but it's still pretty weak. We should change them, and we should use secure passwords if and when we use them. The passwords are very weak. I mean, users often pick something that's guessable, like their daughter's name, their cat's name, their dog's name, for example, and if it's a randomly generated password, now that's often hard to remember. And I can tell you, in organizations that required these strong, hard, random passwords, you'd walk down the hallways, and here's what you'd see. You'd see sticky notes all over the person's desk without passwords that are just sitting there. So we have to be careful with this. We need to make sure password sharing is not going on with our users if we use passwords. Now, so let's talk about something you know. Attackers can obtain passwords through things like observation, network sniffing, database theft, looking at your social media posts. So if it's based on something you know, there are a lot of things that could be figured out. We have to understand that a lot of information has been sent over clear text over the years, not encrypted. There's password databases that are sitting out there over the dark web. And even if it's a password, we can use brute force to generate random passwords. And, that could take time, and it still takes time. But now we can push a lot of that work to GPUs, and we can push a lot of GPUs in parallel processing to break passwords pretty easily. So one thing that's better than passwords is a passphrase. So instead of saying Cindy the cat, well, actually Cindy the cat's a password, but instead of using the password Cindy, it might be something like, I love orange cats like Cindy, or I like tabby cats like Cindy. And that's going to be much harder for a dictionary to get. I still don't recommend using anything related to your pets or anything like that, but you get the concept. It's a whole sentence, and it's going to be very hard for something that's going to be randomly looking for a sentence. And the good news about passphrases is they're not that hard to remember. You can generate a good passphrase, you can keep it, and it's not that hard to remember. So it's a whole lot better than what people do, where they use the word password and then they add a 1, 2, 3, 4, or 5, or 6 after it. You would be surprised what people do with passwords. Something you know could also be a PIN number. And PIN numbers, again, are another category of something you know. Now combine it with something you have, like an ATM card, and now you've got two-factor authentication, and now it's much stronger. We also have to think about password policies in our organizations. We have to come up with a good written policy that'll help an organization understand other people understand how to make their passwords, and that'll apply to the organization's security frameworks, for example. So let's talk about some common password policy settings. We have things like maximum age, which is how often a user must need to change their password. So if the maximum age is 45 days, every 45 days or less, the person's going to have to change their password. Let's talk about password complexity. Now that's going to refer to the number of different character types, like uppercase, lowercase letters, numbers, special characters. And a simple password like 1, 2, 3, 4, 5, 6, 7, 8, 9 is only numbers. Where a complex password will use 3 or 4 variations, which makes it much harder to guess. Password length. So that's going to be the number of characters in the actual password. And it often takes a minimum length of 8 anymore on today's world that we're typically dealing with. Longer passwords are harder to crack compared to shorter ones, especially when things are using the same character type. So you got a long password with 3 characters, it's much harder to actually crack. Minimum age is something else we want to think about too. And that prevents users from changing their password until a certain time has passed. And password policies with password histories are typically enforced at a minimum age as well. Let's talk about password history. So we have to address the process of users cycling between passwords. Cisco 1, Cisco 2, Cisco 3, Cisco 4, Cisco 5, Cisco 6, back to Cisco 1, and then back to Cisco 2. So you'll see people do that, but we don't want them using the same passwords, especially because users tend to use them in the same places, and invariably somebody's been hacked and their passwords have been hacked. So if we combine the password history and minimum age, and then a maximum age, we start to get a better picture of everything. Now let's talk about something you have, like an ATM card. You go to the bank, that's something you have. A token card that you have. Now we're starting to get into something that is harder. Because if you have a token card that generates a random number, the attacker would have to have your token card or some way to see to honestly, and the key to understand how to get the same token as you. So we're talking about something that's pretty significant here with the smart card. It contains an integrated circuit, and it typically adds a lot to security. So we could have smart cards. They store identification or authentication information inside of the machine. The little card has a microprocessor in it, and it may contain a digital certificate or any kind of asymmetric cryptography information, and digital signatures to prove that you are you. Many of these smart cards are tamper resistant in the way they're actually constructed, and they facilitate some very good, strong management of your encryption keys. And we can use these types of smart card readers in authentication, and they're typically used again with the backup like a PIN, so you're getting two-factor authentication. We can also use something called tokens. And tokens are typically a token device or a hardware device. They're typically portable password generating devices, and they'll just display a digit periodically, and they'll keep changing it. And maybe it's a 6 or 8 digit number, and it's going to work in tandem with an authentication server. And what's great about this is these things change, let's say every 10 seconds or every 6 seconds or something like that. So you get it, you have a password, a token. And then the next time you're going to use a different token, and by doing so, it's not like somebody got access to the token, they could keep using your system. It's only good the one time you log in. So let's talk about the authentication process. They're used alongside with other authentication mechanisms. So the user might log in with a username and passphrase and then get asked for a token, and then they'll input the challenge and then respond. Now, tokens are generating one-time passwords, so that's going to significantly increase your security over a static password. So there are different types of tokens. We typically have symmetric dynamic password tokens, and these are going to be time synchronized with an authentication server. And we typically have asymmetric dynamic password tokens, which are not going to be synchronized with an authentication server. And these are often used with the challenge response mechanism. Now, if we deal with synchronous dynamic password tokens, they're going to be time-based and they're going to sync with an authentication server. They're going to generate new PIN numbers at periodic intervals, like every 60 seconds or so, and they'll require both the token and the server to really maintain accurate time. Now, the common use of these involves entering a username, a static password, and a PIN number on a website. Alternatively, the PIN numbers may follow a username and password. So there's different ways you can enter this information in. By comparison, asynchronous dynamic password tokens are going to operate without a clock. They're going to be using algorithms or incrementing counters. They're going to generate dynamic one-time PIN numbers that are going to remain until they're used for the authentication. And some of these models produce one-time PINs that you can use that'll match to the PIN server. So with these asynchronous dynamic password tokens, the authentication process is going to be submitting a username and password, receiving a challenge, like a nonce, for example, and then you're going to use that nonce to generate a correct one-time password. And if the one-time password is entered on the website is correct, you're authenticated and allowed onto the website. Now let's talk about something you are. This is going to fall into that type 3 authentication, and it's going to be used for identifying and authenticating individuals. And here we're going to be using biometrics, which is going to search against a database of authorized users for which the database will have the biometrics. So let's talk about authentication via biometrics. It has to have a one-to-one match. And this is very common in secure access areas because, typically speaking, if the person's unique, only one person can have those actual attributes. So let's talk about some of the types of biometric methods. We can use fingerprints, face scans, retina scans, iris scans, palm scans, voice patterns. So let's talk about face scans. What is it that they're actually looking at? They're looking at the geometric patterns in your face, your bone structure, the angles. Your smartphones often do these kind of things as well. Now, if we're doing a retina scan, and this is an interesting one and an interesting topic, what we're actually doing is we're looking at an actual picture of the retina. Now, that means we're going to have to get the eye very close to the scanner because it's very hard to get a picture of the retina. From my old days in internal medicine when I was a nurse practitioner, I've looked at a lot of retinas in my life. And what we're going to be looking is that blood pressure pattern. And this is highly accurate. Now, the challenge with retina scans that we need to think about some of these trade-offs is we're looking at a person's retina. Now, the retina provides great medical information about the person. For example, if we see something called AV nicking, it tells us that the person typically has high blood pressure. If the person has little yellow spots on their retina, something called xanthoma, it typically tells us they've had a lot of high lipids, like high cholesterol in their life, and we see that. So, are we collecting medical information? And that's one of the ethical things that people discuss when they talk about retina scans. Now, we can also do iris scans, which are the colored part of the eye. And what we're really looking at is it's going to look at that colored area around the pupil. And now it's not as accurate as a retina pattern, but you don't have to get the eye so close to the scanner. So, an eye super close to the scanner might not be good in a pandemic type environment or when, during flu season, for example. Further away from the scanner might protect against germs, for example, but it's not quite as accurate. And it also isn't collecting really medical information in the same way either as a retina scan. Palm scans, where you put your palm down and it scans your palm using infrared light, and it's going to be unique like fingerprints. Now, voice pattern recognition could also be done. Basically, the user talks and it recognizes their voice. This one scares me in today's world because it's pretty easy to replicate voice with AI. So, this one we'd have to be pretty careful with. make sure the system wouldn't be susceptible to AI. Now, nothing's perfect. I'm going to tell you right now. And biometrics are not perfect. Sometimes they deny someone who's supposed to be allowed. Sometimes they allow someone who's supposed to be denied. Use a couple of factors, and that's going to help. Authentication, that will help. We can get something called a false negative. And that's where the user's supposed to be allowed in, and they're blocked. We can also have false positive, where the system allows someone who should not have access to actually access the system. Which brings us into multi-factor authentication, which is using more than one form of authentication. And we can talk about, if we use two forms of authentication, we typically call it two-factor authentication. And it's just based upon the numbers. Now, there is a trend towards passwordless authentications because of the weakness of passwords, and static passwords are considered the easiest to break, and even efforts to strengthen passwords and making them longer and more complex, they're making it harder to remember. So they're not really working out real well. Passwordless authentication typically eliminates the need for users to remember or enter passwords. And we can use things like biometric authentication, fingerprint recognition on a smartphone or a tablet. So practical, what are we talking about? Once we've verified someone in some form of passwordless method, realistically speaking, users can access the application that they need. And maybe a user wants to access a banking app, then they have to pop their fingerprint on there to prove that they exact them and somebody didn't use their computer and they can access to something higher. We also want to authenticate our devices, and we can look at their devices' network logins, for example, and determine who's owning them. We can we want to know who's coming onto our systems and when. And we want to authenticate those devices. And in some cases, we just want to deny entry. For example, we might have network admission control, which basically uses a similar concept, but it's done on the routers and switches. And if somebody tries to plug into the network and their MAC address isn't recognized, they shut the port down so the person can't access the network. So there's lots of ways that we can use this. And we have to be very careful now that we're getting a shift in devices that are used at work. Many people tend to bring in their own personal devices. So if in this world, we now have to adopt our security to make sure that it works. So we might do what's called device fingerprinting, where we basically look at a device and we come up with some unique identifier for that device that could be based upon an operating system, browser specific, or some kind of attribute that we can learn to recognize that device in future. There's also third-party authentication tools. Organizations commonly employ third-party solutions like security auth to identify the provider, for example. Now, with devices, we typically use mobile device management systems, and many of them are now using context-aware authentication. And we can typically integrate that with network access to control to make sure that the only devices that are accessing the system are those that are there. Now, one of the original forms of device authentication was actually something called 802.1x. And this was used for port-based authentication on wired networks or even wireless networks, requiring a device or user authentication before the network access was granted. Whoops, I had a muted microphone. So anyway, well, we are back. I'm having a whole lot of fun. I hope everybody's having a whole lot of fun and learning a whole lot in the CCSK Certificate of Cloud Knowledge training course to prepare you for the CCSK V5 certification and the CCSK exam. This is our last point for today, but we'll be here again tomorrow. So I wanted to see if any last questions popped in from the day. We'll answer any last questions. As a reminder, we have a completely free security architect webinar on Thursday, how to become an architect. We'll talk about the skills we do, what we actually do in the job, the skills you'll need, both business and technical. And it's all free, and it'll be on Zoom, so you can ask any questions you have. So we have that, and it's all free. We also have that completely free study guide if you just joined us that will help you pass the CCSK exam and give you a lot of cybersecurity fundamentals as well. So let me see if anyone has any last questions. And if not, we'll finish on time at exactly 5 p.m. Eastern, which is exactly what we promised, or 1700 hours. But I just waiting to see any last questions. If you've had some fun while we wait for questions, maybe share this with others. Maybe make a LinkedIn post, give a tweet, or whatever they call it these days. Email a friend, because we want to help as many people as we can with this free cybersecurity training program that we're doing here. And of course, that's our mission. So, Chris, we'll wait 1 minute for questions. I don't see any coming in yet. So, give me a hashtag CCSK. Let me know if you're having fun and learning a lot, because I like to know that you're all here. I'll give it about 30 more seconds to see if any questions. And if not, see everybody tomorrow. But give me at least some hashtag CCSKs, or type a certificate of cloud security knowledge, or CCSK V5, or something that I know that you're here and still awake. All right. Wow. It's pretty quiet. I see the first of the CCSKs coming in. I know there's a delay between the time that I say something and the time people can see it. It could be upwards of 30, 40 seconds. So I see that you're all awake. Well, Raj, good to see you. Parviz, very good to see you. I'll see you tonight in class, by the way. CCSK, I love it. This is really great to see so many people here. Okay, well, I don't see anyone here. So maybe give the video a like, maybe subscribe to the channel if you're not a subscriber, share it with someone, and we'll see everyone tomorrow. But please give it a like before you leave if you had a good time and learned something. And if you're not a subscriber, subscribe and hit the bell. So we'll see you on other technology videos to assist you in your career. Cloud architect career, security architect career, AI architect, enterprise architect. We specialize in